Hello, everybody. So welcome to the Cyborg room and the demo PTG. We'll get started now. So first, some ground rules. I started recording.
You started?
I started, yeah.
Okay.
So we have been given some ground rules by the foundation. We are not supposed to move the tables or add any new equipment, even including extension cards beyond what they already provided. So I think something like a wireless set should probably be okay, but we can't attach anything to anything in the room or modify anything. Okay. So we have an Etherpad. We'll be going through that. The Etherpad's URL has been written in the poster board over there. It's Cyborg PTG train. And we'll also be presenting some slides on Zoom. The Zoom number is 663-746-8814. So we don't, 663.
Write down.
Okay. Let me write it down.
Hi, Sandra. The Etherpad URL, the C should be lowercase. C. Cyborg C. Lowercase. Then it looks like uppercase.
I'm going to share the Etherpad in my Zoom now. Share. Okay. So in the Etherpad, we already went through some discussions in the pre-PTG phase. We have some specific timelines put down. So let's start with that. The first one is at line 35. If we're going to talk about the major goals for train, that's in a separate Etherpad. It's linked to the first one. So we can start with that. If somebody's already gone through it and they have any suggestions to be added right up front, we can take it now. Otherwise, we'll just go through it in order. Okay. So the first thing I want to say about the main goals here is that I think this is a very critical and great opportunity for Cyborg. There are things that you get in the train will get probably included many other installers, and we have made a lot of progress on getting alignment with Nova, so that we may actually get that this time potentially. We're hoping for that. So it's up to us to deliver these major use cases in train, right? So the main things are we want to reach an agreement with Nova and merge the patches already put in there. And to get the true integration with Nova, there are some prerequisites. We need to merge the Cyborg pilot branch into the main branch. And also, we need to set up CI, like a continuous integration in infrastructure, at least for FPGAs, because that's another prerequisite for Nova. And if you want to get integrated with other installers like Red Hat, there is apparently a prerequisite that we should move to Python 3. It's anyway requisite because it's going to get our end of life by next year. So a lot of these goals have some prerequisites, but starting from the top, we want to reach agreement with Nova, including whatever that entails. And as it says in line 9, there are some important use cases we want to deliver. One is that we want to launch one or more VMs on a compute host with some accelerators attached to that. It could be FPGA or GPU, it could be multiple FPGAs, etc. We have two broad usage models. By the way, you can stop me anytime. If you have any questions or comments, just stop me, please. Okay. Yeah. So the first one is what we've been calling as device as a service, in which the user says something like give me a Tesla M60, and I'll manage it myself. Or give me an Intel RER10 FPGA with this bit stream, etc. That's what we call device as a service, because it's getting a blank device and managing it yourself. It also requires some knowledge on the part of the user. So it's meant more for power users. The next one is what we call accelerated function as a service, in which you say, I want to offload gzip, and I've got this CUDA driver in my VM. Or I want to offload IPsec, and I've got the Intel's OPAE driver in my VM. So you just mention what function you want to offload and what driver you have, and you should be good to go. So you want to deliver both of these in the same cluster, and that's a scheme we worked out with Nova. And once you create VMs, obviously you want to delete it with appropriate cleanup. There are different kinds of cleanup you want to do, like either clean up the user data from a GPU or FPGA. With FPGA, sometimes you have to wipe out the bit stream itself so that no other user can use the same bit stream. It happens to be a confidential bit stream. So delete a VM with device cleanup is next one. There are some critical devices you want to support just to get some basic support. We can add to this based on your feedback. I just put in a few of those here. I know that Huawei is bringing more devices here. We'll talk more about that in this PTG. Other thing is we want to add APIs to upload bit streams. Why do we need that? Like the bit streams of FPGAs go into glance, but they need some metadata. And if the metadata is wrong, it will affect Cyborg's functioning. So we want to ensure that you give the bit stream to Cyborg first. We will do the validation and parsing and everything, and then put that in glance, right? And of course, Cyborg's basic job is to manage inventory of accelerators. So you want to have some APIs to list what devices you have based on various filters, like which ones are in use, which ones have, let's say, BMC version older than 1.7, things like that. So there should be various ways to list your inventory and track usage from Cyborg.
Is it going to be one API or seven?
Currently, I'm thinking that it could be just a get/devices kind of API with various query parameters. Only one API, yeah.
So why are you tracking the firmware version in Cyborg instead of Ironic?
This need not be ironic use case. It could be just a Nova-based VM use case. So you got all these devices, and you need to just know the inventory of what you've got.
But nowhere than to do the inventory on its own. I will call this Ironic within gets it to the database.
Yes, in the bare metal case, yes. If you are not dealing with bare metals, then who does the management? It will be Cyborg. So Nova's got just the plain PCA devices in its whitelist, right? So it's not going to know about the devices in detail.
No one needs to know because no one does the question is where does no one get the information? The inventory device and the version of the device from where. So
Are those things will be reported by from the list and then the Cyborg will report.
So just to clarify that, there are two kinds of properties you're dealing with, right? Some which influence scheduling. Like you want to say something like, I want to schedule a VM on an FPGA with IPsec function.
correct. That's no one.
Right, so no one needs to know about that.
That.
Yes.
Don't get me wrong. No one needs to have the database of the information.
Well, the way we do it is we're putting it in placement.
Okay.
We'll create resource providers in placement for each device.
Okay.
We'll put traits there on each resource provider indicating what property it has. But those traits are only those relevant to scheduling. It will not be things like BMC version and flash capacity and things like that. Those things will be in Cyborg database as additional attributes and users can query that. So only those relevant to scheduling go into placement, everything else stays within Cyborg.
You're going to bump into all sorts of problems of the life cycles. Because right now, in order to do life cycle of the firmware and BIOS and everything else of Node, you go through the array. Oh, but for those devices, you have to go outside of that. Customers will barf. Because the last thing they want to do go through different types and figuring out which order things.
So we do have a proposal for integrating Cyborg with Ironic that's coming up in the cross project tomorrow morning.
Okay.
But it's probably a little bit further down the line. First thing I'm doing is to integrate with Nova. So the non-barometric case.
Absolutely.
Right.
I'm just trying to figure out where the best way of getting the data to populate the traits and stuff like that.
I would.
You'll need to put a node one way or another. Cyborg has a data that's fine, but the life cycle will become problematic.
Right. Even in the Ironic case, it seems to me that the Ironic guys don't necessarily want all the device details in their database. That's what.
Actually, they get the whole thing. So when you do introspection of Ironic, you get every device which is available.
But only at the level of PCIDs. You don't necessarily know about FPGA
so they're
details,
not
for
using
example.
all the devices. So to be fair, they get that, they can dump it into the Swift database, but it doesn't mean that they're using all the devices to do anything. Because frankly speaking, they only care about the devices customers, well, they already worries about right now, and the only thing they worry about right now is making sure NICs are set up properly, RAIDs, disks, networks, execution, stuff like that. So those are the things which are part of what I would call initial deployment to configure the node and be able to power cycle the node, because all the power cycle goes through Ironic.
Yep.
No one can do it themselves.
That's correct. That's right. Yeah.
So I don't know if there is any specificity which needs to be done with respect to power cycle, with respect to the devices, which I expect in some cases it might, but in general I would expect not.
Okay.
But there is some coordination need to happen.
Absolutely. Yeah, I agree with you for lifecycle management, etc. You need to work with Ironic or Nova.
Nova is a must.
Nova is a must. So
Yeah.
yes, that's
No,
part of
we
it.
don't have any scheduling, so you're done.
Right. Yeah, exactly.
Okay.
Yep. Thanks. Good point. Okay. Sure. Okay. Were there any other comments on the APIs needed for device management and querying? Okay. Good. Okay, cool. And the next one line, between lines 15 and 16, really, is the APIs for shell update or firmware update. So this seems to be a common requirement for a lot of different devices, whether it's even if it's like one of those Huawei's Ascend, apparently it's got some firmware in it, right? So we could do that with an API which patches the device effectively. Let me define it in more detail. So can you think of any other super important use case which needs to be delivered in train? Okay. And are people okay with this list of use cases?
So, do we need to document what should happen during the upgrade?
Sorry, document what again?
What happened during the upgrade?
Yes. So yes, we need to upgrade from V1 to V2 smoothly. That's one of the other requirements as well. Yeah. Okay.
Just one second. SmartLink is like when you say that the CI with FPGA, SmartLink, you consider FPGA is part of the SmartLink or SmartLink?
So people mean different things by the word SmartNIC. So which one do you have in mind? What kind of SmartNIC?
We understand that FPGA and the IO controller is part of the SmartLink. Like Intel, the 810 is part of SmartLink. Sorry? Yes, yes, absolutely. I just see FPGA and GPU here.
Right.
I just want this question. So you consider the smart thing you need to add, or smart thing when you say because FPGA is part of it, so it is covered here.
Okay. So I think people mean two kinds of devices when they say smart NIC usually. In one, you've got a regular NIC, but implemented inside FPGA, so it can be flashed easily. And it looks to the host like a regular NIC. It will operate with a regular Ethernet driver, etc., etc. So that's one category. Second category is what you could call an accelerator card with networking.
Yes, this one.
That's, for example, the Intel Packline 3000, which was announced recently. That is part of Cyborg because it's going to expose the FPGA separately and the NIC part separately to the host. So FPGA is visible to the host. You have to manage it lifecycle along with the NIC. So that will be part of Cyborg for sure.
So in the CI, why you don't mention smart thing? Why don't you mention FPGA and GPU?
Okay, so we do need to bring some CI into the picture for Nova integration. Exactly which device you put in the CI is kind of up to the vendors also. So each vendor can bring their own set of devices in however way they want. There needs to be some minimum CI for Nova integration though. Right. So we do have intentions to bring the major Intel products, at least from Intel's perspective, into CI. For other products, it's up to the respective vendors. Okay. So once we had all these new APIs and potential database changes, we also need to enhance Cyborg client. So right now it's still in version 1. Even the pilot code does not address version 2. So we need to add that from scratch. And then I put a question mark on GPU CI and 20th because I want to hear from other participants whether they can support it. Can the Lenovo people support some GPU CI?
You, you mean use a real device?
Yeah, real or maybe even a fake one perhaps.
But now we have the fake driver UT.
Okay, but would you have something more specific to GPUs perhaps? Like,
No.
no, okay, just the fake drive. Okay, all right, fine. And
Excuse me. What is the difference from API version 2 and 1?
a lot of the Nova integration stuff is coming in version 2.
Oh.
So in version 1, we got a certain stage, we're able to set up a database schema and all that stuff. But with version 2, we are making the changes for Nova integration.
So now version 1 is not cannot connect to the Nova on the Cyborg.
That's right, yeah. Okay. Okay. So we have to move to Python 3. So any questions about that or comments? I actually don't, we haven't even tried it, so I don't know how much work it's going to be. But anyway, Python 2 is end of life by next year. We have to do it. So, okay. And just some suggestions beyond that. I think we can improve troubleshooting. We can probably add more logs in various code paths, etc. That's my ideas here. So if you have any comments on it, please let me know.
Question, Sana.
Okay.
You mentioned that the Python 3 support would be needed to be completed in 20 weeks.
I think so because by Python 2's end of life by next year.
Yeah.
So I think they're putting a requirement in every project. Yeah.
Should be a lot of work.
Should not be or should be?
Should be or should not.
I don't know. Until you try it, I don't know. So, yeah.
Maybe not so much.
Yeah.
Because have to
Yeah, most of the
Yeah.
most of the code in Cyborg we import the Coleman Oslo library. Yeah, just a few code like Java part. Yeah, it may have some works to move to Python 3.
I think our testing framework is already in Python 3.
Yeah.
Yes. So it's mostly just some other code paths. That's right. Okay. Yeah. Okay. Sure. So for troubleshooting, do you have any thoughts on what else we can do to improve? So I would suggest that we should include all of these as criteria and code reviews. When we review code, we can look for logs, exceptions, are they putting asserts, etc. In particular, I think it's useful to have asserts to indicate what data type each function is taking and what data type it's returning. If it's taking a list, you put assert saying this parameter is a list, things like that. So it'll make UT also easier. Yep. Okay. And the another important area is improving documentation. So even in the Stein cycle, many people were asking for our API reference and other details, developer documentation. So we started moving on that. We have some base in Stein already. I think we can improve upon that. There are some specific suggestions below. We'll get to that in a short while, but I think that will be another important goal. Yeah. So I don't know who added the line for RISC-V support with FireSim.
I did.
You did? Okay.
So,
Can you please pass it?
something I'm working with Howard. Yeah, something I'm working with Howard and Lucifer.
Okay.
And I have a project that's not a policy. This has really been able to out in the US. So let's say it's basically using RISC-V processors on FPGAs to do data center simulation.
Okay.
It's a pure academic project.
Okay.
And we're talking with them in this ecosystem to OpenStack, using Cyborg.
Does it look like an accelerator? Like is it a PCA card?
Well, they're running on top of Linux FPGA, FPU90 FPGA.
Okay.
So basically, what it does is I guess they simulate data center workflow on FPGA by implementing tiny little RISC-V processors on the FPGA.
Okay.
And then they use in the cloud, they use a farm of FPGA servers. They say they can use 10 or 100 FPGA servers and have 100,000 compute hosts.
Okay.
Just basically you can run this as a simulation setup.
Okay. So if the RISC-V is part of the FPGA,
Yeah.
then it's really FPGA support at the point, right?
Right?
Then it's really adding support for that FPGA product.
Yeah. So, so we need to provide a basic API and functionality, and they will develop the history.
Okay. So what I'm not understanding is why is it different from FPGA support? It's already supporting other FPGAs, right?
Yeah. Really like. So currently they want to port this from the US to OpenStack. There's still a lot of
Okay.
reprogramming and all this stuff. So they're waiting for us to get it to ready state so that they can start porting their stuff out to OpenStack.
Got it. Okay.
We'll try to figure out an environment for them.
Okay.
So that we're doing this because, let's say, upon we come out to utilize this as a service in Excel. With OpenStack as a service.
Sure. Okay. Sure. So do we have the real hardware for this one?
I have one from my team.
Okay. Okay.
I'm still working on that to give it to give access to the.
Okay.
It's really hard, okay, the US university, right? Collaborate with always.
Okay.
We're,
Right.
we're trying to collaborate with them under the level.
Okay.
Yeah, we'll.
Okay. Sounds good. Cool. Okay. Then here's item for generic driver. I think already had some discussion. I already gave some comments in that spec, but looks like you are, yeah. If you are thinking in terms of enhancing the base class for drivers, that makes a lot of sense. Definitely we need to do that. But if you're thinking of one driver for several products, that may have some issues because when you have a driver, like you enable or disable separate drivers. If you got one driver for two different products, disable it, all those products are gone. You can't say that I'll disable only for AI but not for security.
You're saying.
So you said is upgrade, so deploy or upgrade interface. So we can't. I think your comments for the argument of the upgrade interface.
Yeah. So. See,
You mean we can't just use the file to do some upgrade, just use glance image.
What I'm saying is you could have a generic base class for drivers.
Yeah.
You put a lot of code.
Yeah, it's our goal.
You could create one driver for your, let's say, AI chip. It is very thin driver. It gets most of its code from the base driver. It only gives things like vendor name and other things. Similarly, another small driver for your security chip, the vendor name and other things. The advantage is that you can now do configuration per driver. You can do dependencies per driver. If you need packages for security like crypto, you can do it only for that driver, not for the other driver. And thirdly, you can enable and disable separate drivers.
So you're just commenting on the benefit of having.
I'm saying the term generic driver, it doesn't mean it's a single driver for several chips.
That's not one.
Okay.
What it says is that we have a just try to avoid
Yeah.
Yes.
So we just a generic driver. So for example, we have a interface like upgrade, and FPGA can use this upgrade to upgrade some using JTAG to upgrade FPGA static binary, right? And also upgrade can use for GPU or NPU like device to upgrade the firmware. So this is it. So if we have a common parent driver, we can also call one driver directly.
Okay.
Otherwise, we have to write some code like if FPGA do something, else if do whatever, what other driver do something. So it's
like abstract driver. So each vendor need to inherit from the dynamic driver.
Yeah. Okay, then that makes sense. Okay, sounds good.
Yeah, that's all.
But we do have to talk about what goes into the generic driver and what goes into the agent. Because something is common to all drivers, it goes into the agent instead of drivers.
Yeah, agent can call the parent driver direct.
Okay, sure. Okay. And the next item is Ascend NPU support. We want to talk about it, Deacon?
This is we will support the NPU device, and the main use case is first about upgrade binary, upgrade firmware, and the The second use case is touch, because it has so it depends on nuance.
But you said there are two categories of devices, right? One is this NPU.
It's just like the GPU device. You can touch directly, nothing like some FPGA.
But you got some security chip and an AI chip, right? All the two different things. One is security processor, some crypto processor of some kind.
I think we were just talking about this edge.
Okay.
So everything we need to do is just to align an engine driver, right?
Yeah.
Okay. So there is no separate.
Also do two things. Once we translate the code for
Right. Okay. Right. Okay. Sure. Cool. Okay.
So if it's possible, GPU and FPGA driver can implement inherit from the parent generation driver in some.
Yeah.
But it's not urgent.
Sure.
So how you have that article on guiding how to run
There is a high level document to make the developer to write a driver, but for the detail.
But that doesn't have the generic driving.
Okay.
Yeah, it's not for the generic.
Maybe after we have the generic.
Usually change the.
Yeah.
So maybe tomorrow we could talk about the generic interface of the generic driver.
Yep.
Maybe cover the FPGA or GPU.
Sure. Okay, so those are the main goals. To me, it seems like a lot of goals to have for one release. So I think we need to prioritize. I think the top few are definitely high priority. Would you all agree? Like reach agreement with Nova, implement the main use cases, Cyborg client, CI and Python 3. I think we should also add this generic driver and ascend NPU to that, right? We can reorder it to make it higher priority. The troubleshooting and documentation you have to do anyway. Troubleshooting is something which we'll be doing ongoingly, right? We'll be adding logs, asserts, and other things as we do code reviews for every patch, right? So any comments or thoughts on how much work it is for one release?
Just for train, right?
It's not just for train, yeah.
Depends on how many people
Okay. Yeah.
can work on it and how many hours.
Just curious, how, so you're the only person that can contribute. Do you have any people in your team?
Shinran is there. JH team, yeah. JH team, yeah.
People?
Our team,
Yeah.
about 3 people.
Oh,
So how many people you can put outside work?
Oh, yeah. 3 people can work for Cyborg.
oh, very nice, very nice. Good. Cool. Thank you.
Is that the KPI for these people?
Okay, so this seems more doable then. Okay. There are also some good to have goals, like improve unit testing frameworks, because we do have some unit tests, but it seems to be mostly focusing on the happy path, like everything is going fine, goes and tests that. We need to put more negative tests, like force error conditions, all of that, right? That's one group. And I'm interested in seeing integration of the installers. In the last cycle, we already integrated with Cola Ansible, so that's a good progress. I'm talking Red Hat guys. So Red Hat is looking for a lot. They want us Python 3 and a lot of other things. We're going to integrate the RDO first, and also with Triplo before it can go into OpenStack platform or HOSP. So there's a sequence of things to be done before it can get to the installer. That's one track. Other track which I'm interested in is Airship. Airship seems to be getting more popular, but to get into Airship, first you have to get into OpenStack Helm. And to get into that, first you have to integrate Loci, which is a lightweight OCI containers for OpenStack. So you already have the Cola containers, so it may be a little tractable, but a sequence of steps there also. Anyway, so trying to think through all of that stuff. Others have already pinged us about own app integration. The China Mobile has been talking to us. OPNFE is another area of interest. So there are a lot of things going on there. Any comments on that? Okay.
Good.
Yeah.
But for the ONAP, OPMV is for long term.
Longer term thing. I don't know. It will not happen in train. That's why I put as good to have. It won't necessarily happen right now. Yeah. Right. Yep. Okay. In terms of documentation, we have contributor documentation like for developers. The driver development guide from Zheng Hao is useful. The human also started writing something. We have another person in Intel who has a lot of operator experience. He has put up many OpenStack clouds in his career. So he's willing to help with our documentation as well. Config options, user guide, there's a bunch of things there as well. So we have to follow up. So any thoughts on the documentation? Okay. The last section is almost like a miscellaneous thing. What I could think of, I just put it in there. Feel free to add your own thing. Eventually, it will go into some kind of storyboard tasks. But I think we have got some issues right now. So, for example, for FPGA programming, we always use the same tool, but it should really depend on the bitstream type. If you've got an OpenCL based bitstream, we have a tool called AOCL for that. And for the SPAC N3000, there's yet another tool called FPGA Flash. So depending on what bitstream you're dealing with, we should use the right tool for that. Just not that.
This should be covered by the driver, right? Because the programming go through the driver.
True. But how would the driver know what bitstream it is if it's just getting some raw binary file? We need to get some file type. That file type may need to be in the glance image metadata. So we need to add that in the metadata, get it to Cyborg agent and give it to the driver.
Yeah. So I think all we need to add is just that drivers should be able to figure out.
That's right, yes. Okay.
You mean adding some extra information when the FPGA driver report to agent?
It will be more like extra information on the bit stream. So whoever uploads the bit stream should indicate what type of bit stream it is. And the driver will use that information to choose the right tool.
So this information is reported by who or by?
Whoever uploads the bit stream. If the operator or some third-party bit stream vendor are uploading it, when they give it to Cyborg API, you should also put some metadata indicating what kind of bit stream it is. Okay. These are mostly relatively small ticket things. Do you have any other thoughts on our goals for train? Do we all agree on these goals? Anybody thinks no? Do we all agree on these goals?
Yeah.
Okay, cool, nice. Okay, good.
I think using a standard priority.
Yeah, yeah.
So many work and maybe it's better to set the owner of this kind of goal.
Mm-hmm. Yes, there's a separate section on owners. Is it not? Yeah, it's probably in the main Etherpad, not here. But
Can we use storyboard maybe after we finalize the item?
Yes.
Yeah.
Yeah. It's cool. Yeah. So I would propose that we should move the generic driver and assign the NPU support right after Python 3. So all of those will be required, right?
Oh, by the way, there's some code which is related and it can be used now. There are some old code in the Cyborg.
Okay. You will delete all that stuff, you mean? Yeah. Yeah, okay. There's some examples in that some things to do section. There's objects accelerated.py, for things like that. Yeah.
Like GFDF, we don't have that.
Right. Yeah. Okay. Okay. So I'm going to just swap the last two and put them above. Okay. Okay. So everything until line 29 is no high priority. Others also we want to bring in as much as we can. Is it fine? Okay. So if there are no further comments, we can finish this topic and move to the next one. So the next topic we have in the Etherpad is mapping UIDs to names. So right now, even in the pilot code, we're using IDs for a lot of things because that's what we get from the hardware. So the main IDs are using are one ID to indicate the region type in FPGAs and another one to indicate the function type. So if you want to translate that to names, the main thing is we want some assistance from the vendors. Okay, so the device vendor provides some kind of a mapping from region type to a name, and that is given as part of a driver package. Sorry?
The name is what is referred to its name.
What is the name before?
Like name like a string. So for example, if your region type ID says like 3AFB12, instead of using that, we want to say something like Intel Pack RER10.
This is the device.
There are two kinds of IDs you're dealing with right now. One is the region type, which will correspond to some device name, right? Other is a function type, which will correspond to something like gzip or IPsec or whatever. So two separate things.
The device is the service name. Function is the service name.
Right. But we will.
It's abstract for the name. This name will be referred to which traits, placement traits are.
Yes.
Also
Yes.
okay.
That's no. It will be, many of this will be part of traits. That's part of the motivation. See, when you call the placement with all its trait names, there are limit on how long the URL can get. So when you put UIDs there, they're worried that it's going to spill over. So if you use names instead, it'll be a little shorter. It will help with that also. It's also more easy for the operator to use in defining device profiles. So the thing here is like if you got a region type ID and the vendor gives you a mapping from the IDs to names, we can just use that. We can just say that every device vendor just gives the mapping as part of the driver package. So whenever Intel gives a OPA driver, just give me a mapping along with it. We'll start using that.
Sorry.
Yeah.
My question is, is function ID identical to image UID?
No, it's not. Image UID is a glance bitstream UID. It's what was assigned by glance on that particular cloud. If you go from one cloud to another, it'll be a different UID. Whereas the function is just goes with the bitstream. So whoever developed the bitstream says, I'm doing a gzip. So that gzip ID is the function ID.
Oh, I see.
Yeah. So you could have multiple bit streams implementing the same function. So for example, you may have some OpenCL application and you generate a bit stream for ARIA 10 FPGA and you generate another bit stream for Stratix 10 FPGA. Now 2 bit streams but the same function. So bit stream ID and function ID are not the same.
Give you an example of what especially the YAML file content.
Okay, let me actually go to the other Etherpad. Okay. So which line are you referring to, Lee? I'm now looking at the map
So
names ID.
you propose there's a API for adding the map, right? Adding the name map.
Right, yes.
Right. So yeah, there. So apply for the
Okay.
So, just wondering what's a YAML file content look like?
We can define the details in some spec, but basically it'll be like a key value pair almost. It'll just simply be like for this region ID, he has a corresponding name. Just list all those pairs.
Oh.
Yeah.
So you can batchly update a list of regions.
Yes, in one shot you can do all of that, yeah. So typically when a vendor releases a new driver, it may support a list of devices. So for that, we'll give a list of
Is
those.
it a good idea to allow people to do this as a batch, or we just one by one?
When you say one,
like having an API like this.
if you allow multiple updates in one time, the single update case is a subset of that. You can do one by one if you want to. I can do a batch update if you want to. So we get both. And for Cyborg, it's not any extra work, right? Essentially, just get a YAML file to consume that. So this is only a proposal, right? If you want a different name for the API, something you can do that. I'm calling it a patch because you already have some object, like a map, just updating it.
Who is using it? Who will be using it?
So the employee is using out of Cyborg. So you other service like Nova or business.
No.
So why we need this API? The name mapping, right? Just like some libraries in stuff. It's not API interface. So I just want to know why we need this API.
What I'm thinking of is that the cloud admin gets, let's say, a new device, like a new GPU or a FPGA, whatever, right? Along with that, he gets some kind of a YAML file from the vendor saying these IDs correspond to those names. So he just installs the driver and he puts this file into his API. That's all he does. Now he's got the names. Yeah, the cloud admin. Once admin does it, now he can start using names and device profiles. If you look at the device profile, if you don't have these names, he has to put IDs in there. That's much more difficult for him.
Generally, the driver, like the driver from the vendor should know that.
It may come as part of your driver package, but I'm not sure if you can necessarily embed that into the driver itself. You have to ask every vendor if they're okay with putting in the driver. It's not just Intel alone to say that, right? Every driver has to do it everywhere then. NVIDIA may not do it. Then what do you do then? And the other thing is,
where I just I'm okay with basically we need some standard or some method or utils to do the transfer from the ID to name. But I just think the API, if we export the name ID API, it's just a little weird. But,
little weird.
yeah.
Okay.
My feeling is that specifically open API, whenever you do this, it's not really necessary.
It's only for admins, right? It's not for everybody. Only admin can do the update. So only admin needs to use it.
Admin needs to know mapping, and this mapping actually it's very device specific, right?
Yeah.
And then it's very device specific. Why can we use
Because every driver may not implement it.
Well, we can have a default implementation. If the vendor wants to implement a mapping, they can go ahead and do that so that they can save the trouble of calling. But we are encouraging them to do it. But if they don't, we can just do the default something. And then we allow them to do that.
So part of the motivation here is that there are two kinds of names, right? One is the function ID and function name, others region ID and region name. They're coming from different sources. The region ID mapping is coming from the device vendor. The function ID name is coming from some bitstream vendor. It could not be Intel. It could somebody else could synthesize their own bitstream and put that in the cloud, just like with AWS.
Yeah, about that. So when you program that bitstream on that bitstream, that's the moment. You can put this mapping for image memory, right? So when you do the programming, at the same time you update mapping is mapping. So that it's transparent to the user, right? You don't the user or whoever that's programming the update. Like they can just prove this and say whoever is uploading this bitstream, right? He enforced them to put it back to you.
Okay.
And when you load this bitstream two sides, right? One is actually doing your program. The other is a part of the business. One of them is to update back to the
So how would it work in a pre-programmed case where you set up your FPGA ahead of time? Maybe your vendor is probably giving you some pre-installed bitstream. So there is no bitstream in the cloud. There's no metadata or image in the cloud itself. You just got some pre-installed cases.
Because first of all, this is a shell bitstream, and it's the driver's shell to what's being loaded. The driver is bitstream.
But you won't get the name, right? All you're getting is ID from the hardware.
Yeah, but it's vendor's job to find out what this ID is mapped to.
So that's where it gets a little tricky. Like if you ask every vendor driver to do this ID to name translation to the driver itself, I don't know how many will actually do that. Whereas if you do a separate API, even the operator can do it. Either the vendor helps by providing the mapping, or the operator himself says, I'm not going to use IDs, I'm going to create my own mapping of IDs to my own names. The operator could do it himself if he wants to. You're not relying on drivers or anybody else. You can get started.
I have another question. Can operator change the mapping or not?
Yes, the operator invokes this API. So he can change the mapping. He can provide his own names, add his own things, whatever he wants to do.
So the function ID by device vendor and the function
The region type ID from the device vendor,
yeah.
the function ID from the bitstream vendor.
Both operator can change the YAML.
Yes, yeah. So the vendors can help by providing some mappings. If they don't, operator can do it himself.
Oh, I see.
Yeah.
So as they like, operator like.
Yeah, it's easier for the operator to use it in device profiles then. He'll use names instead of IDs.
So the default mapping is provided by the vendor or vendor.
We would like that, but I don't know how many vendors will actually do that. So we can ask them to do it, but if they don't do it, operator can do it.
I think that for the bitstream ID, why do we need to maintain this part? I think when the operator uploads the bitstream, they know the bitstream ID, the bitstream name.
Right?
Yeah.
So you can just put some function name there. Yes, that will work if all the bitstreams are uploaded first. But if everything's pre-programmed, like you already set up everything and is using it. Yeah, there are many possibilities. I agree that you may not need this for bitstreams if you're uploading the bitstreams yourself.
Yeah.
Just get the metadata and start using that.
Yes, so the map is maintained by class now. Yeah.
Mapping, it needs to be in Cyborg too, because when Cyborg gets a device profile with a name, it needs to translate that to an ID and use that. So we may, that's why you have an API going into Cyborg, right? We'll take the bitstream, parse it, before putting it in Glance, we'll update our own database.
When we create a new device profile, we can pass the name of the bitstream, not the bitstream ID.
Yes, you can, in a device profile, you can refer to bitstream ID or to a function ID. But with this scheme, you can refer to function name like gzip. The operator could say, this is a device profile for Intel Pack Aria 10 with gzip version 1.1. Yeah, okay. We can think more about the driver option. If you all think that we can somehow get the drivers to do it all the time, you may not need this API. But we need some way of translating it.
I think we should make it simple to users to use this kind of operations. You mean the users need to first create the YAML file which contains the mappings and then pass it to Cyborg.
Not the users, but the admin. The admin may need to do it, but if he gets it from the device vendor, even that step is gone. He just takes the file and just pushes it to the API. So the vendors should help. If the vendors don't help, the operator can still do it himself.
But I think it's for the admin. It adds difficulties for the admin to operate.
It'll be more tough for the admin to use IDs directly in the device profile, right?
Yeah.
So that's the thing.
IDs.
Right. Right. Okay, so but anyway, I'll record suggestions here. You can also write your comments directly in the Etherpad. So one comment is like, can we get the drivers to include the name ID mapping?
Yeah, I think I prefer we figure out something to make this set transparent to the domain.
Is the driver comes out of here, or the driver comes out of the part of the operating system?
There are two kinds of drivers we're talking about. One is Cyborg driver, which we provide.
Okay, the
Other is-
specific to the individual version of the device.
Yes, there'll be one Cyborg driver for FPGAs, for example, another for GPUs, etc.
Okay, maybe, okay, this is so you can have a common API across them? Okay,
Exactly.
got it.
Yes,
Okay,
yeah.
got it.
It's not the hardware driver, a Cyborg driver.
Is it in the user space or in kernel space?
User space. It's our Python code running as part of OpenStack.
Okay, so, but that's part of the Cyborg. It's included in the Cyborg itself. So
Yes.
if you deploy the Cyborg, you have that
Yeah.
on
That's
the
right.
compute nodes.
Yes.
Okay, got it, okay.
In addition, you've got the vendor provided driver,
Okay.
which could be part of the OS. Like if you're getting an Intel FPGA, you need to put the OPAE drivers as part of your host.
Got it. So question I have is the following. For the Cyborg driver, is there a dependency on the version of the vendor driver per release? And where is it? If there is one, where do we document it? And you know, check in when you do the deployment that you have the right version. Or even worse, if you have to have a different common API version, depending upon what the underlying driver version is.
So ideally, the Cyborg driver should not depend on a specific version of the underlying vendor driver. The purpose of the Cyborg driver is to do a matching between the two sides. So we don't want too much hardware dependence in the driver itself.
Understand. But if you look at, for example, sender drivers
Okay.
or others, they have a dependency. Dependency comes in two forms.
Okay.
If you have a driver from the vendor,
Okay.
and that driver requires certain specific user space libraries,
Okay.
which are versioned.
Okay.
It may be as simple as specific version of the Python of variation or something else. They are, you know, put as a requirement and very well kind of documented per driver for that. And basically we do deployment and check dependency. And when you do deployment, it pulls the right version if it's not available. But the most important thing is document what are the dependency and what are the versioning.
Okay, sure. That's good. It's a good point. Yeah. So we should do that. Yeah.
I think OpenAI driver also have the version property.
Yeah, that's true. So
the dependency in the dev stack is well.
for Ubuntu 18.04, not for other older versions. Yes, that's what he's pointing out to. Correct. We need to document that. Sure. Drivers, dependence.
Dependency and version.
Right. Okay. Yeah. Okay.
After this exact call, after this I would then also update this.
No, place will see only the name in that case.
Yeah.
So the
But
device.
before you do this, you put a policy API has probably a wrong. Or not wrong.
Nice.
And it's probably already reported
Right.
by the nature of our environment.
Yes.
Right? And then you update it now.
Mhm.
You have to trigger the replacement update.
That's true. And then delete the old traits and put the new traits.
Yeah.
Yes.
So maybe we should down by the driver, since the driver reports the replacement to the agent.
Driver should do some like notify the driver found that okay this version of this is changed the feature. It's okay.
But when we update the map, it's updating something on the Cyborg. And the driver probably only scan with whatever is going to be.
The problem with the driver doing it is that the driver reports something per device, whereas it's common to all the devices which the driver handles. So you don't want this on a per device basis, right?
You mean
The name ID mapping is not for each device separately. So right now, driver reports everything on one per device. Instead, we want something which is across all devices for that driver.
right? But when you report like the driver, the driver reports replacement, it has to have a name. Right? Maybe at some stage you could figure out that's where you do this, right?
Right.
So the driver needs, first of all, the driver needs to try its best itself,
Okay.
right? The reports of fixed replacement. And then if you could, it's still report fixed replacement, but then you want to get some more or something better. And then until someone comes in, calls API, update the mapping, and then we trigger it again. I'm just not so clear of this timing. The driver runs through after, you don't know where to do it. And you call to your device or system, boot up, starts. And then if at this moment you could figure out what you're going to do. I hold up here, but here something comes here and update it.
No, it will both be independent processes. So driver will do whatever it's doing. The API will go and modify. This is like what you said, right? The API comes in, we need to go and delete some old traits and create new
So you
ones.
still allow reporting to report
Yes. So driver continues to report only the IDs. When it comes to the conductor can check to see if mapping exists or not. Mapping exists, we'll start using it. If it doesn't exist, we'll use ID as it is. And I see, okay, I should also document that. There's a kind of if you go and delete the old traits, you'll have a problem again because the device profiles may already be referring to the IDs. The operator has to know to go and redo all of the stuff.
Yes.
That's the problem there.
So basically, before you figure out the ID, ABC maps to name of them. They update the ID ABC maps to IP7. And that's the moment you update the placement. Spiritually, the placement gets updated on
Are you talking about region type IDs now or function IDs?
whatever. This update both now.
Okay.
So that's what I said, maybe I will update both region ID. So whatever it is say functionality or originality, I don't care, but there might be some cases, I think we were trying to cover the case where drive by Cyborg couldn't figure out this pattern, right?
Mm-hmm.
There were some corner cases that this might happen.
Right. Okay.
This other guy is trying to cover that case. But
Right.
when it happens, you couldn't figure out the mapping. What if you just don't know it yet until someone calls it a guy, correct it, and then because you don't want to mess up the placement.
Right.
By adding unknown stuff in there.
Right.
Mess up the right?
Yep.
Maybe if you couldn't figure it out, you still.
Okay.
Then if someone reported it, we'll call it. And then like if someone comes in correcting by whatever, either on this API or survivor or reconfigure the driver or some whatever way, right? And then this update.
Okay. So given all these issues, let me just think about what it takes to not have this API. So could your Cyborg GPU driver, for example, include all the GPU product names based on the PCID? If you just give me the product names, you can't do that, right?
We don't need that. We don't have something.
It will be like kind of a table within your driver. You translate PCIDs to the appropriate product name.
I don't know, so maybe, let's say, the only case where I can think this problem I have is under Carl preloaded history. That's the only case that Cyborg was preloaded.
For function ID, yes.
Yeah.
Right.
All the other scenarios, Cyborg should be able to figure out by itself.
Sure. Okay.
Right? If we only want to cover this single case, why not we just put it in Cyborg account? Right? We just put it in the Cyborg account. Say, okay, let the people who is plugging this code in the system deactivate the Cyborg account / Cyborg. That's the initial statement. Right?
Cyborg account will get very complicated then, because for every bit stream you have to put some entry.
I know, but we're trying to cover a very tiny case here, right?
No.
By adding a REST API on the system.
Okay.
I just feel like we're over-engineering this.
For region ID, it's another important case. You're saying this put in the driver,
We should be able to figure out that.
but the Cyborg driver, that's what I'm getting at. If you rely on the vendor driver, you may not get it. But if you use a Cyborg driver for that, you may be able to, you can control that part. It's within our control.
But if you, let's say for a entire PTG, you load a static region, put a card in there, where you scan the PCI bar space, you should be able to figure out what's the district, what's static region.
We'll get the region type ID from the hardware, but not the name.
You got the name, but you got the ID is fine, but this ID should be unique per name, right? There must be a way for the driver to figure out what it is. If the driver has that.
Driver sees only the ID in the hardware. Driver has to provide the name itself.
Yeah, but the vendor specific, right? Rather there should be a what is ID should not be.
Correct. That's what I'm saying. To put a Cyborg driver.
So that the driver.
When you say the driver, like the underlying vendor driver, the Cyborg driver.
The vendor driver.
That's
or just the vendor has to provide their driver on the process. Figure out the information. I do have Cyborg driver to repackage all that information and get it reported up to right? So the Cyborg, maybe we can leave it to the Cyborg driver. But default, like the vendor Cyborg driver, right?
Yeah, that's what I'm getting at. Right. Let the Cyborg driver figure it out.
Yeah,
yes.
So that part is good.
Okay.
So I still think, yeah, it's useful. I mean, I'm not saying this is, but I still think it's kind of overaging by adding an API to cover a very tiny thing. Right. That's my idea.
It's not just okay. I think the function ID and pre-program case a tiny case. A lot of telcos are doing it in a pre-programmed way today. That's one thing. That will be a majority for telcos.
The program case, right? They're basically using this FPGA as a basic chip, just put a low register there, put it in the system. They probably won't even change it for a month, right?
Yeah.
They use it just as a regular accelerator. They don't
Right.
really sense it.
Right.
In that case, they totally put it to cost. It's very like static.
I'm more interested in the region type case than the function ID case. Function ID, we can figure something out. But for region type, you have to embed in the driver. Unless the driver says this region type ID corresponds to some name, there's no way we can figure it out. That's why the vendor has to provide it, either in the Cyborg driver or in the vendor driver.
Let's say put it this way, the vendor can literally do this. They figure out the ID from the driver, like by scanning the mouse space. They use this ID, right? And then what they could do is they can access some of their old database online, retrieve the name from their old inventory, right? And then use that to go to. They can totally do that, or they can hard code this something in their driver. If they have new product, they just update it. Update it back. That's right. In this way, I think we use our one. You don't have to add this one. And then you can leave this one for the
Region ID. Good. Okay. Sure, we can think. Okay, sure, yeah. I think we are agreeing. I think. Sure.
It's very, very
So I want to point out, pre-programmed is not a tiny case because it could be a dominant one for telcos.
What I'm saying is, it is big case for pre-programming, but I think pre-programming case can be covered by some way.
Okay.
Not using.
Okay.
The only case that this is absolutely necessary is probably the function ID. You have a function, you have a user logic code, and then you could figure out what that is.
Right.
And you need some manual work to update this.
Right. Okay.
That's the only case I can think of.
Okay, fine. So I think we agree that we want to translate IDs to names, but it doesn't have to be at this API. Right, okay, sure. That's fine. So we can try to think of alternative mechanisms and put a spec for that. Sure.
So now could you put the summary in the line photo?
Sorry?
It's time for the next talk.
Next, okay, sure.
Make a summary.
Yes. Yep, okay, sure. Yeah, that's fine. So, yeah, we cross this thing, okay. The next one is networked FPGAs. So just give me one moment. Okay. I'll go back and clean up the ether pattern of what we agreed upon. I can review it later. Okay. So are you all on Zoom? So would you be able to see my slides? We have now moved on to the networked FPGAs topic on the main Etherpad. So I'm sharing some slides. So basically, there is interest in supporting networked accelerator cards. We already announced the Intel Pack N3000. It's going to be shipping in volume later this year, but it's shipping to customers as samples even now. So this seems to be in a category of devices where you'll have one FPGA plus one or more NICs. I'm sharing it already on Zoom.
Is it Google Doc?
I had an old Google Doc, but now I got new slides. I will put the slides after this PTG. Yeah, I'll put a Google Doc and link. Okay. Okay. So the FPGA exposes some PFs. One of them could be used for management reconfiguration. If there are more PFs, you could use them for SRIO and other things. The NICs have one or more PFs too. Okay, and each of those PFs support SRIOD. So it could be a standard NIC supporting some standard NIC driver. So this kind of card mainly meant for telcos. Okay. Oh, sorry, I don't have Zoom.
I
Okay.
just reading behind it.
Oh, sure. Okay, cool. Okay. Okay.
Sorry.
Okay, no problem. Okay. So I originally said that we are going to pass the NIC BF straight to the VNF VM and telco use cases. So you may not need any direct interaction with Neutron. So this portion is still kind of a work in progress. We're still trying to figure out how we are going to support cards like this. We have some proposals, and that's what I want to fly by you guys. So this portion that we don't need Neutron interaction may need to be kind of rethought a little bit. But before I go into that, here's a general usage model for these telcos. Here's one or more of these accelerator cards, and typically dedicate them to one NUMA node. So we have, let's say, 2 of these cards for NUMA node 0 and 2 other cards for NUMA node 1, for example. And then when you bring up your VNF VMs, we will affinitize them with specific NUMA nodes and tie them to specific devices. And we already pre-calculated how much network bandwidth and how much compute is needed for each device, each VM, and how many VRAN cells it can support or whatever it may be, right? So everything is pre-computed. So if we vary this even a little bit, it's going to affect your latency or jitter or something like that. So the exact layout is important. And also we need to kind of map some VFs to each of the VMs. So one VM may get from multiple VFs in the same card, but not from multiple cards. Whereas one card may feed into multiple VMs. So that's the picture here. It's a one to many.
But this is just only a celebrity workload or just pass through, right?
Just pass through, right. So typically in most of the NFV cases, you want pass through to minimize latency and jitter anyway. Yeah. At least I have not heard of any other use case so far.
Both for SRV and DPDK?
Yes, the DPDK would be inside the VM.
Inside the VM, so
and that will be doing its own pole mode driver with this BS attached to it.
And the number of PFs is dependent upon what the NIC capabilities is.
Yes. Okay. There could be multiple PFs per NIC, and each of those PFs could have their own VFs.
Okay, so that's another point of contact with the ironic guys because they are setting up the NICs.
But this is the NFV context. So
doesn't matter, they have to set up the NICs.
In this one, there's no ironic at all because only Nova on Cyborg. They're setting up VMs and running it there. So Cyborg will discover all these NICs.
Okay.
And it's going to report them to, well, at least it's a proposal. Nothing is done at this point. FPGAs are automatically candidates for Cyborg, but we are saying that NICs also.
I'm not worried about is the NIC I'm worried about.
Right.
Because
okay.
you have multiple different traffics, both for the OpenStack itself, as well as user traffic. And it's a question of dedicating the NICs or splitting the NICs either on PF level or VF and then on top of the PFs VLANs or VXLAN or whatever else.
Okay.
To separate the traffics.
Well, these NICs will typically be used only for data traffic.
Okay, so then we need to be precise and it's dedicated to the tenant traffic and not used for anything else.
That's right, yes.
And then probably you'll have one NIC or one pair of NIC to be for the floating IP and one for the between the VMs of the same tenant.
The way it's been presented to me is that the multiple networks, the external space, for example, uplink and a downlink for a VRAN, you need to map that to these PS in some form. So we are not so worried about floating IP versus fixed IP because Neutron is not managing its networks. It's directly mapped in, and only external network is managed by Neutron.
the operating system is all of the pre-installed, so Nova does not have to worry about all that stuff. It's all pre-set up somehow magically beforehand.
Not that's one of the catches here. We want to deploy VMs with NUMA affinity.
No,
That's
I
not
understand
preset.
that. Correct, but the point is, I mean, let's say you have a NIC. You have two variations of that. You either have a NIC fully dedicated, or you have potentially multi-port NICs, and you have a ports bundled together with appropriate level of bundling to have the HA level of capabilities.
Right.
That creates all sorts of fascinating things with an opinion.
Right. Okay. So normally with the SRI, you would have used the PCI whitelist, right?
Yeah.
In the PCI whitelist, you would have put some trait like FISNet 0 or FISNet 1 for each physical network.
Yeah, no, I understand that. Yeah, we can get number of PFCs dependent upon the capability of the NIC. That's fine.
But in this case, we are not using PCI whitelist. We want to use Cyborg for the whole thing. So you don't need to create any configuration list ahead of time. So we are going to discover the network somehow. I still have to figure out how, but put as a trait on this NIC resource provider. So if you can mark it as a trait, then you can even do scheduling based on that. You could say, give me an FPGA with this telco workload plus this network. And the VM gets placed there appropriately.
And the trait will be per PF?
Yes.
So we have a higher level entity than the NIC, which we need to expose to the scheduler.
Yes, via placement. This is what Cyborg does already. Okay. It's an extension of the current Cyborg model. Currently, we're doing only for FPGA. Now we're including NICs also as resource providers and modeling that in placement with traits and everything.
Yeah, I do hope it's well documented.
Always just proposals at this point.
No, I understand it, but even as a proposal, you need to be careful because in order to know to schedule it properly, it's not trivial chunk.
Right. So the NUMA affinity is still work in progress in Nova. So it's not been fully agreed upon, but other things we're hoping to make forward progress on.
And that makes sense. Yeah. Out of curiosity, have you guys scheduled to present this or have a joint meeting with Network HQ?
Unfortunately, we didn't get the level of clarity. We can actually schedule a neutron cross project for this thing. Okay. We didn't even know if we necessarily need a neutron interaction for this thing in the first place.
NUMA interaction is one thing. Network H, I think it's H computing working group is another. It's two different entities. So I would recommend, guys, that we schedule some joint session with H computing working group. Unfortunately, had only one meeting during PTG that was to be the so they are of course, people are scattered all over the place, but I would suggest you contact Iltico. Okay. She is the one who is coordinator for the working group and try to schedule a joint. It doesn't have to be during the PTG. It may be one of the calls, 1 hour, 2 hours, just to go through together because clearly there is a lot of the joint requirements.
Right. Sure.
So,
yeah.
So how does this happen? How does each company prepare this course of all of the stuff?
Okay.
How do you want to be aware of which of the BFs that were assigned to that?
The first cut proposal basically said neutron need not even be in the picture because we can treat each of these VS PCA pass-through NICs and just attach it to the VNF, assign some random MAC address to each VF. This is all random, it doesn't matter too much. It's not a neutron managed MAC address range. That was the first cut proposal, but after that I heard a need for sometimes assigning specific MACs to specific VFs. So we need to get neutron somehow into the picture. So I've been talking in this PTG. I have something like an enhanced proposal, which is like on top of the basic proposal. So I'll get to that in a short while.
Just not just discussion, just reminding
the edge computing work group.
Uh-huh.
There's a mini list for that.
Okay.
Maybe the Cyborg community can subscribe and to get involved in discussion.
Sure.
Because I know a lot of edge computing customers are very interested in accelerator.
Okay. So it's part of OpenStack discuss, or is it outside of that?
Is that hosted by,
Separate.
Okay.
is that hosted by Shen?
Shen is also only hosts the local PRC local meeting, but it's a global.
Utica is the one who is driving that. It's official open stack SIG.
Mm-hmm.
And they have two calls, one for geography.
Okay. So this is a general usage model. Going one step forward, the requirements can be summarized kind of like this. In general, we want to have a certain number of card instances per compute host. On each of those card instances, a certain number of FPGA VFs, certain number of NIC VFs. So that will be multiple NICs, each with multiple VFs. So all of us at first and second NIC, I need to rephrase that really. It should be like for each NIC a certain number of VFs. So we need multiple NICs because it's all sized to a certain amount of bandwidth and throughput and everything. So each NIC has certain capability, right? So we put multiple NICs to get the necessary throughput.
So when the VM is deployed, VM knows which PFs it needs or how many it needs?
Yes, the user request has to say exactly how many you want from each NIC. And within the VM, it only cares about which network it's connected to. Somehow you have to get the network connectivity information into the VM. It's all DPDK inside, but you've got a bunch of VFs showing up inside the VM. So the DPDK based application needs to know this VF is going to the uplink and that VF is going to the downlink.
So what is connecting the PF to the VM outside of the OpenStack?
PF is not connected directly to the VM. Only the VFs are connected to the VM, the DPDK.
So what attaches the VFs to the VM?
Cyborg will do that.
Okay.
Yeah.
So maybe where is the Cyborg project lives in? I mean, is it part of Nova, part of Cyborg?
It's an independent project. So it's registered. We got our own releases as part of OpenStack. We've been releasing since Queens. Mm-hmm. We've got our own API server, conductor, and all those components. We are integrated Cola and Sybil as an installer. So it's an independent project on the same footing in terms of governance as Nova, Neutron, and anybody else.
So why is it not introduced to the board as one of the pilot projects?
Then the Cyborg itself has been introduced and...
No, Cyborg is there. I'm talking about Sidebar. If Sidebar should be expected to work with this, it's part of the infrastructure project, why it's not introduced to the foundation similar to Sterling X or Airship or other ones?
I'm not sure I follow the question. There's only one Cyborg project.
Okay, where does it live?
It's part of OpenStack. If you go to review OpenStack.org, you'll see our patches. If you go to Git OpenStack.org, you'll see our code there.
Okay, it just doesn't have a PTG meeting this time, or?
This is the Cyborg PTG. So maybe I'm confused.
Okay, there's a Cyborg and there's a sidebar. No, it's
No,
the same thing?
same
Okay,
thing.
okay. That's where I got confused.
Okay. So we have one set of code. I was mentioning we got a pilot code for no integration. That's sitting a side branch. It's also upstream. So everything's upstream.
No, I understand that.
Yeah, okay.
That I understand.
Yeah.
Okay.
Okay. So basically, there are some requirements to support these telco workloads. So this is generic definition of what these accelerator cards look like, and the NICs may have similar PCIDs and capabilities, but they are connected to different networks. So based on which network they're connected to, we have to treat them differently. So the VM deployment may ask for certain number of PFs from network 1, some peers from network 2, etc. Sorry, not peers, but VFs. So we model the PF as resource providers and VFs as resource classes normally. So we're going to extend that in this case, and that's what I'm getting to. Okay. This is actually a fairly brief set of requirements, but do you have any questions about this so far? So for the current workloads, you don't need anything like IP address, only the MAC address needed. It's more like the vRAN, other layer 2 deployments at this point. But leaving Neutron aside for now, we have a certain proposal for Cyborg, and that's in the next thing. So basically, we consider the possibility of using a separate resource provider for each of these, like one resource provider for the FPGA and one each for the NICs. But if you do that, we have problems in getting them co-located. You can't be assured that all the resources come from a single PCI card. So to prevent that, we are making this proposal, have only one resource provider and placement, and Cyborg will take care of all the components within that.
So is this sub-deployable one-to-one?
It's a one-to-one mapping to RP, resource provider. But within that deployable, there are multiple resource classes, one for FPGA and one for each NIC.
Because you have 3 sub-deployables and 3 RC.
Yes, each sub-deployable will contain one RC, you're right. But that's not what's exposed to placement directly. While the parent deployable is exposed to placement as a resource provider. So placement sees one resource provider with 3 resource classes. So it's guaranteed to come from one card.
So the first one is RP and RC, right?
Mm-hmm.
And basically that RP represents the deployable and RC sub-deployable.
I wouldn't phrase it in that terms. RC is the inventory of a deployable. The deployable contains a number of accelerators, right? So for example, if it contains 3 accelerators of type FPGA, then the FPGA is one resource class, and I've got 3 of those, as an example. Maybe it becomes a little clearer when you go to the next slide. So here's the change we're making. The top one is a current device model. The bottom one is a proposed model. So the top one basically are saying that we got one device with multiple deployables. Each deployable has multiple accelerators. The device has a control path ID, and there's a bunch of attached handles going with the deployables as well. That's the original model, right?
The new deployable is one for device.
Yeah, correct. In the new model, it's one for each of these. It's a superset of the old model. It should be able to handle the old ones as well as the new one. Yeah. Uh-huh. I should do that. I'll do it right after this PTG. Yeah.
Yeah, just put the pointer back to
The Etherpad. Yes, sure. Yeah, yeah.
You have the PFs running already, and you didn't everything to follow, and I don't remember how the PFs work.
Okay.
But we do break it into the PFs and we assign the PFs. The only problem I have because the Cyborg, when I want to assign the PF to the VM, for example, for outside of that, basically manually signing. Because there's no API call to tell me how to get the EMs because we have to.
Which device are you talking about now?
The NIC EMs.
Okay, I see. But the NIC PF pass-through. We have a VNIC direct physical type, right? In Neutron, you can do a VNIC direct physical, which means you're doing a PF pass-through to the VM.
That would be good to know. Yeah, I don't think we have done that. So again, I don't remember the detail protocols.
Okay.
That's why I wanted to propose the slide that one of the guys will know better.
Sure. So in standard Neutron, you got VNIC type normal, which is like a regular OVS type VNIC.
Correct.
Then you got VNIC type direct, just as how you pass through from a VF. Then you've got VNIC type direct physical, which means you're passing the PF itself, the whole device pass through.
The full VFs, yeah, we knew how to do it. So there are two problems. We broke them into the multiple, how to pass it specific. The other thing that was not needed. What we have done, we took two ports on actually different things. We bonded them.
Okay.
We drove the, and then we carved the bond into PFs. And that's that.
Okay.
Oh, because that's how you got HA. Without that,
Right.
when you goes down, and well, you're done.
Right, okay, okay.
And I don't remember all of the details how the intricacy to percolate that and attach it to VM.
Okay, okay.
That's why I said, okay, that looks very familiar, but I don't remember. And I remember it was specifically one stem. There's no API for that. You have to attach it. Kind of administrative action.
Okay.
To attach it.
Right.
And I don't remember top of the head how it was done.
Okay.
So I wanted to see and then ask the guys who did it.
Okay, sounds good. Sure. I will post them online. Okay, cool. Okay. Yeah.
Yeah. After the change in the proposed, the deployable structure may change to the nested.
Sorry.
It come nested.
Yes, it's nested. Correct. We already have deployable tree model, right? In Cyborg, we already have notion of a parent UID for every deployable. So you can create a tree. In the tree, these three will be the leaves, and the parent one will be the root.
As for the before this proposal, the in Coco's implementation, yeah, it's not nested. Maybe it will
We just have deployables, but not sub-deployables.
Correct. Yes, in string release, that's correct, yeah. But you do have the parent and root UIDs. So you can leverage that to build this tree structure. Just said the sub-deployable's parent will be the parent deployable. Just form the tree, and only the topmost one gets reported. So some changes are needed. So those changes are on the next slide. So basically, you have to merge the traits and resource class of sub-deployables and the parent deployable and report that.
It's more than 10% of the audience.
Yes, but he's also.
There are two.
Which one? A given NIC could have even 4 control path IDs. It could have 4 PFs or 2 PFs, depends on the particular product.
So your control path ID right now is yours.
Yes. Yes. We call it a control path ID only because in some cases you cannot create some PDF. Like in Power VM and all, you have to use some location code and all kind of stuff, right? So only reason why I call it a control path ID. Otherwise, it's just like a PF.
So what's the relationship with, let's say, you have 2 control path ID per on this FPGA. There are two accelerators in it. Do they have any mapping relationship?
The accelerators will map to the VFs rather than to PFs. So at least for the product we have, we are thinking of two PFs because one could be used for programming. And the other one is the SRIOV capable one, which expresses VFs.
So one of them is
I'm sorry?
one of them.
One of them is only for programming and management.
Right, so the other one is for resources.
Yes.
In that case, do we need to track them?
If you're assigning the FPGA VFs to the VNF, yes, we need to track them in that case. So if you look at the previous slide, apparently in some workloads, you don't have to assign FPGA VF at all. In some workloads, you have to do. That's why I put a maybe in the purple line. So depending on which one you're doing, you have to track it. Okay. So a lot of things are work in progress, but I think the main takeaway is we want to represent the whole device as a single resource provider to ensure locality. That's the main thing. That's what we discussed in the pre-PTG discussions as well. And
back to the previous next.
The next one?
Yeah, I think a slide which show what changed.
Oh yeah, okay.
Maybe the next.
This one, the next, okay.
Yeah.
This one?
Yeah.
Okay.
Coco just want to know how many chains in the Java OVO part.
Okay.
I want to figure out the workload.
In the previous design, and there is no tree structure, so it is a big change.
I think that is probably the easiest part because you already have the tree infrastructure. You already have parent UID and all of those things. The main change will be in merging the info. You take the resource class and traits in the sub-deployables and merge them with the parent and then expose that to placement. That's the biggest change. Forming a tree, I think, will be relatively easy. The driver report will say that I got 3 sub-deployables and they form a tree with parent deployable. Driver will just give that to you.
So you mean we don't need to change the driver OVO?
That's correct. You don't need to change that. Yeah. At least I think so. Do we have that tree structure in the driver today? I think it should be doable. If it's not, there'll be a small change.
Yeah.
Yeah.
But right now there are no for deployable. We only have deployable, but we don't have something to track sub-deployable.
Right.
Yeah. So we can. What I care about is just should I set sub-deployable in the next layer of the deployable or in the same layer of the deployable?
It'll all be a single OVO. Yeah. Oh, okay, I see. Okay, you're saying how do you structure the whole tree? Okay. Yeah. You will create 3 deployable objects, one for each sub-deployable, another deployable object for the parent, and set up the UIDs. But I know what you're saying. We need to work that details out. We need to figure out how to represent the tree in the driver OVO.
Yeah.
Yes, okay, sure, okay. Got it, okay.
I prefer we not change the tree. Maybe we can add some field to identify the parent and the child.
Okay.
Yeah.
Okay. And then we have to publish custom resource classes in each sub-deployable.
Yeah.
And that we have to create, that's the main change. Also custom traits. Mm-hmm. I think we have some placeholder for traits today.
Yeah. It's not in trade list, but in.
Okay.
Xian on this part, and I think she didn't update it to the current driver OVO.
Okay.
Yeah.
Okay, that's fine.
So maybe you need to update that.
Okay, sure. So if you guys think this is kind of complicated, then we can actually get some NOAA people to come and talk to us with alternatives. I already spoke to them. My understanding is anything you want to change in placement is going to take a very long time. So if you want to change any of those things, like you won't be done train or even maybe even you. So if you want something to be done by trained, it has to be in Cyborg's control. If we, yeah. So, yeah.
So the last one, the number 4 point, control path ID must correspond to deployable.
Yep.
But right now it's device, right?
Yes.
So we need to change the DB.
Yes. But anyway, I have to change the DB because we're missing some fields for even for NOVA.
I see.
Yeah.
So the first thing is to figure out what changes in the DB.
Right. Right. Yeah.
Always start from DB.
Right.
Let me check the composition of in the slide 3 or.
Sorry.
Let me check the composition in the picture. Or picture? No.
This one.
This one.
Okay.
The top rectangular is identical each other.
Yeah, the two NUMA nodes.
Two new and in the same machine.
Same host. Yes.
So one physical server have 2 FPGA boards. Right?
It may have even more than that.
I see.
The two NUMA nodes, like typically we use a 2-socket server. So typically 2 NUMA nodes. A socket is not same as a NUMA node, but we're kind of simplifying it a little bit. You may put 4 cards, assign 2 cards to one NUMA node and 2 cards to another NUMA node. That's also a possibility. It depends on the exact deployment.
So do this VM0 can connect by more than 2 cards?
No, each VM gets only from one card.
I see.
That's the important thing about co-location. All the VFs and FPGA stuff should come from the same card for one VM. But one card can support multiple VMs. Right. Yeah. Okay. So I think this is going to be a lengthy topic. So I just want to introduce it again. And there is a proposal for some neutron based interaction based. It's just based on what we had discussed in this PTG with some developers. So this is all just work in progress. Maybe we can take it in more detail in some Cyborg meeting later. Right? We're kind of running out of time for this topic, right?
So you mean associate device profile with neutron port? What's that used for?
So you create a device profile, and then neutron. If you want to provide like MAC addresses and QoS for every one of those NIC ports, you'll create a neutron port for each of those in this proposal, and then associate device profile with that port, and then change NOVA to query that. There's a lot of things which are changing here. So it's just a proposal based on some recent discussion in this PTG itself. So it's a little up in the air. So we need to make it more solid and get their buy-in. Yes, all is part of VM creation.
So that's doing this neutron part is the logical part.
Logical port, yes.
I think the device profile is just look at the flavor. If we bind the device profile with the neutron part, so this device profile cannot be reused.
You can, right? The device profile will say like, I want to get that nick of the particular trait. Or the resource provider of the particular trait.
But
It'll-
the port is assigned to the device profile. It's
No, device profile name is assigned to a port. You can create multiple ports. All of them could have same device profile.
with neutron. So it's not a real neutron port, just a concept that I need a neutron port.
It's a regular neutron port with one more field.
You mean
Assume
the,
that
the ports, the port, you mean in the neutron, neutron DB, there are ports, ports table, you mean that ports?
Yeah.
But it will change a lot. Maybe I think, maybe there are way that we didn't need to change normal part to implement.
If we can get some agreement that we don't need to change the MAC address for VFs in the train release, we can skip all the stuff. But if they want that MAC address assignment in train itself, it becomes more complicated.
So it's a cross project with neutron.
Yes, and also a bit of Nova. Nova also has to query the neutron for the ports and do additional stuff. So I hope we won't have to go into all the stuff, but if that's a requirement, we'll see how to do that. Anyway, so for now, I think we can kind of table this. We can discuss it more in some Cyborg meeting. Once I get more clarity, I'm just kind of sharing it here to show this is what we're kind of thinking about, the kind of problems we're facing and some proposals we're looking at.
So is this proposal recognized by our neutron?
I discussed with Sean Mooney, who is both Nova and Neutron. In this came out of a joint discussion. Nobody has heard about any of these things. Okay. Anyway, so let's take a short break and see what needs to be done next. So this was supposed to go until 3:30, and it's just at 3:30. And next one is a very short discussion, then we'll take a break after that. So the question is, how do we support different FPGA flashing tools? Like for example, if you have a regular bit stream for Intel, we use a tool called FPGA conf. That's what we're supporting today. But if you have an OpenCL based bit stream, even for Intel, we use a different tool called AOCL, Ultra OpenCL compiler. So, but if it's this PAC N3000, the network FPGA card, use a third tool called FPGA Flash. So depending on what bit stream it is, you have to use the right tool for programming. And the question is, how will the driver know that? How does it know what bit stream it's getting? So the
different bit stream with different kind of tools
yep,
to do programming.
yep.
Different history, different type of history.
Yes. Yeah. Right. So
Here we have this 3 tools here. All from Intel.
all from Intel. Yeah. Xilinx may have even more. Right. So I don't know about that.
Recently, Xilinx developer show some activity.
Oh, really? I didn't know that.
Not here.
Not here, but have they
Yeah,
in the Cyborg meetings? I haven't seen any of them in Cyborg meetings. Okay. So anyway, if they want to participate, they're welcome to come. Sure. Yeah.
One comment on the tool.
Okay.
So two sets of tools. So one comes directly from the vendor,
Right.
of the FPGA, NIC, and so on.
Right.
And there is another set of tools which will come from the integrators like Dell, HP, and so on. Because they will not support direct tool from the vendor because they have a single tool which supports the entire server. And they will integrate it to that. They might have it internally as a part of that too, but that's not the one which should be exposed.
So FPGA flashing tools, right? How will Dell have any tool for FPGAs?
They will incorporate that in their tool, how they support all of the, how they support all of the BIOS and firmware and everything else. And if somebody will try the thirds, basically as soon as you try to burn the firmware using tools which are not supported by Dell, well, good luck supporting the entire server from that point on. You just violated your agreement on the support. Similar to the server, to the the distribution drivers. Oh, you install your own private kernel libraries? Perfect. Go right ahead. The rest support is to you. We just violated all of the rules, the agreements which you signed for the support. I just want to be very careful with defining in such a way that we be supporting those ones.
Okay. Good point. Thank you. Sure. Okay.
I have to take one phone call with that.
Okay. Sure. Okay.
It's also almost the time to go. After this talk.
Right. Yeah. So anyway, guys, my proposal for the subject is that for each bit stream that associates a metadata kind of file type, it could be extension of the name. Like you put the name, could say myname.gbs or myname.something. The dot something will indicate what type it is. Or you make the file type a separate metadata itself. It'll be cleaner to have the file type a separate metadata, I think. Don't link it to the name, right? Then Cyborg can track all of that and pass that file type to the driver. And the driver should have some mapping of file types to its own tools, right? So that's up to the driver then.
This we have an idea for that. We haven't get involved in this discussion.
Okay, who Lee?
This week.
Okay. Hey guys, can we please focus here?
For the discussion, have you opinion for that?
Yeah.
Maybe after this discussion, we can have a break.
Break, yeah.
So now one question: is the tools limited or many?
There could be more.
Could be more.
Xilinx may provide more things.
So I think Cyborg should not maintain these tools. I think the vendor which the stream developed knows which tool they want to use.
Yes. So that should be part of Cyborg driver.
No, not driver.
Okay.
I think because it is bitstream dependency.
Okay.
So I think when the operator or the vendor uploads the bitstream, they should upload the dependency tools.
I see, but if you are calling the programming, Cyborg programming, you should, and the driver should do the programming, and then the driver should know which tool. It's also in Cyborg driver.
So what I'm thinking is put the file type as metadata and also the tool name like FPGA conf also as metadata. Okay. So this person was saying that if you go with HP or Dell, you may have to change the tool. In that case, the administrator can simply go and replace the tool name, whatever he wants to do. But by default, we'll put FPGA conf, FPGA flash or whatever. We'll set up some defaults as metadata and rest you can do yourself. Right?
If different bitstream need different tool, if we have 100 bitstream, we need 100 tools to.
It's bitstream type.
Type.
Bitstream type. So you may have some bitstreams such as synthesized from RTL, so there'll be FPGA conf. You've made it from OpenCL, you need AOCL. But for a whole chip update, we need a FPGA flash. Those are three things we have today.
So maybe we should set a default, you mean?
Yeah, because when somebody gives a bit stream to Cyborg API, it'll set some defaults. An operator can go and override that. It can just go straight to glance and edit the metadata in glance.
Sorry, how do you think about putting this in the Cyborg iPhone font?
How will that work?
Well, you need the Cyborg font or allow you to say it's Cyborg. Actually, again, the Cyborg font will Python font will do the chat. All is the so in that way we don't have to do it. We don't have to expose
That's an interesting thought. Okay.
sorry, maybe I don't know.
Yeah, I didn't figure what you talk about.
Sorry, yeah, go ahead.
Okay.
I think you mean in the grounds we should specify. We should user should define which type of the tools this bitstream use.
Yes.
That type
When you
of-
upload the bit stream, also put some metadata saying file type GBS, the programming tool FPGA conf.
Yeah.
Put all of that, and Cyborg can set some defaults for all of those.
Yeah.
Some has to come from the user or the API user. Some is added by Cyborg. The operator can always go to glance and change it later.
Another question. Does it have version? The tool?
Oh, you mean these tools? You mean? Oh boy.
Yeah.
Okay.
Not
That's possible. I don't think we have it today. I don't know about Xilinx, but for us, I don't think we got any versions today. But it could change later. Oh man, yeah, that's yeah, that could become more complicated.
So right now, does Intel FPGA driver support this kind of tool?
No,
Or
only
just we use the
it is only FPGA conf today.
okay.
So in the Intel booth in the summit, we had a genomics demo just using OpenCL. So we could not use AOCL there. So we just did a pre-program model. It's programmed ahead of time, and that's it. Yeah.
They don't use Cyborg to program the
Yes.
genomics.
It is programmed ahead of time and just use that. Yeah.
So this tool should be set up when installing Cyborg, right?
Yeah.
This is a requirement of installing.
Yes. Yeah. So you have to put the right dependencies. Each driver has to put in all its tools its own dependency. Right. But the point about versioning is a good one. So we have to say, what about tool versions? I don't know how to handle that. Okay, we need to think about that. Okay, so but it's good discussion so far. I think we also lost some of your audience. So we'll take a break now. We'll start again at 4 o'clock.
Another question about the version of the tools. If the version is different, does the tool have the same?
Okay, start the recording again now. So now we are looking at line 51 of the main Etherpad, driver support for various devices. Oh, okay. Okay. So question is, what are the new devices which you want to add? I think we already discussed Ascent 310. So if somebody wants to talk about it, well and good.
NPU?
The NPU, that's Ascent, right? Okay. So do you want to talk about timelines a little bit? So we want assigned driver in train, right? So do you need to propose a driver spec?
I think maybe the semantic driver need a spec. Then
Yes.
other type
Maybe not.
is too vendor specific.
That's true. That's a good point. Yes. So do you want to write a generic driver spec?
Yeah, maybe two spec. One is for the generic driver spec event. The second is maybe it's an that's a vendor driver need
specific.
yeah.
Okay.
Yeah,
Sure.
spec.
Okay.
You mean the two spec for one device, for one type of
No. The generic driver is a parent. Is a parent refactor.
Okay.
Design refactor.
Okay. So you already have one of those specs.
Yeah.
You already have one spec just for the generic driver.
Yeah, the generator is a complete. It's submitted, but the isn't is not submitted.
Yeah.
What is second one? Placement?
The AC.
Sequence. Oh, okay. Oh, okay. Okay. Sure. Okay. Sure. Okay. Okay. Fine.
Sorry, I have a proposal
Yeah.
about the YouTube CDP.
Oh, okay.
No, okay. Right. It'll be easier to hear. That's true. Right. Right. Good. Okay. Okay.
Okay.
Just
Much easier.
much easier. Right. It'll be easier to hear. Okay. So for SmartNIC, somebody wrote like Netronome. Is somebody wanting to own some Netronome driver? And how do you do that?
I added the maximum genre, but I think maybe I want maybe if okay, I think not in this this cycle, not in
Okay.
yeah.
Sorry?
Yeah.
Should be no problem.
Low priority. Okay. How about vGPU support?
We don't have the VGPU.
Yes, but do you want to enhance your driver to handle AGPUs?
But it looks like a Nova solution, just a temporary.
It depends on which Nova developer you talk to. You came to the forum, right? The Cyborg forum.
Yeah.
So,
I
right, when you mention vGPU, like some Nova developers, no, we do vGPUs, we want to do pGPU.
think mentioned that
The resistance come from like existing operators that are using the VG. They don't have enough integration switch if you want to buy a new operators.
You're talking the forum, right?
Yeah.
The forum guy was not even using vGPUs.
Okay.
See, he's using something very simple. That's why PCA whitelist is working for him. So that's why he's not eager to switch. For many others with bigger deployments, I think PCA whitelist is a bigger pain point.
I got some inputs from the iTech. iTech, it's a company which doing NLP, and they have maybe nearly 100. iFlyTech.
iFly, okay.
It's a Chinese company which doing NLP.
Sorry?
Then NLP is NLP.
Audio recognition.
Ah, okay. Okay.
AI, very famous AI company.
Okay,
Yeah.
okay.
And he said they have nearly 100 GPU resource pool.
Okay.
And he said, "Oh, I don't need the I don't need the vGPU because we need as more GPU as many as possible to train the model. So they think that the GPU is not that required.
Okay, okay. So I think you need vGPUs mostly for graphics. If you're dealing with offload or compute offload, you want to take several GPUs and give it to one VM to handle big data. Whereas if you're dealing with graphics, you want to split one GPU. Sorry?
Many GPU to one?
One VM
Oh,
for doing big data, AI, and all that stuff. Whereas if you're dealing with graphics, we want to split one GPU into many and give that to multiple VMs. So it depends on the use case.
So mostly most of the respective feature is not to manage vGPU, but for the physical GPU.
Okay. So you're saying physical GPU support is sufficient. Okay.
yeah.
But I think Cyborg cannot also manage the physical.
It, yes, yeah, yeah.
Yeah.
Okay.
That's a value also the value.
So we are concluding here that vGPU support is not something that's aimed for train, correct? Okay. Yes. Yeah.
But I think that's fine for Cyborg. That's not a stopper for Cyborg to support.
Well, we should, if we are supporting the action, to support the order.
With vGPU, the main challenge is architectural. When you expose vGPU of type 1, you have 4 of those. And for type 2, could be 6 of those. Depending on which type, the inventory will change.
Yeah.
So when you change the configuration type 1 to type 2, the inventory in placement itself will change. And that's a main challenge for Cyborg. With Nova, they're doing it in their own way somehow. Here, the FPGA are not changing the inventory number today. When you reprogram bitstream, you're not changing the number of your accelerators inside one region. Today. Yeah, in the future, you may get bit streams with multiple accelerators. Uh-huh. If you reprogram the shell, yes, the inventory might change. That's true. Yep. That's a good point. So we don't have any specific plan to do update of the device in that case, in placement. When you do a reprogram shell, you have to do a diff with the previous device and adjust it.
Let's say the operator wants to update or upgrade
Mhm.
if the operator shell is showing change, it's totally changed
Mhm. Right.
I think Simone have mentioned that difficulty is how to manage these two, maybe vGPU and physical GPU together. So there some kind of, I think it's a challenge. Like one GPU tab is only for PCI pass-through and the other one is for vGPU scenarios. And how to manage it.
Okay. Sure. Sure. Okay. Any other device like? Yeah. Do you want to add more ADS and train?
I think the train is possible. Yeah, we can list it here. And also beside the Movidius, actually we have a device to put the Movidius chip into PCI E. That's the most important use case for the source.
Right.
So
So right.
So if Movidius is in PCI
No, Movidius is in US.
I see NVIDIA is in
Yeah.
USB, but the chip
Chip. Yeah.
it can be
Yeah, a different kind of product.
Which that would be like what the on the board is.
Sorry?
So there will be one that
Yeah, it's a 16 chip, and then PCIe device, and then plug into the server. It's a very good.
So you are saying it could be in train.
Could be into yeah.
Okay.
Yes.
is that owned by Xi'an?
Sharp.
Driver. Okay.
It's doing that, but for the upstream, I think can help Sharp.
Okay. So any other devices?
No, no, comes to mind.
Okay.
My question is, FPGA is for Intel FPGA only?
It's open to all vendors, but I've not heard from other vendors. Yeah.
So the
Yeah.
category.
So we had participation from other vendors last year, since they kind of dropped out. I think Jeff mentioned some name from Xilinx. Okay, sounds good. Cool.
Who added Manila?
Sorry? Who added Mellanox? I don't know.
I did.
Oh, you did? Okay, cool. Okay.
So smart.
So you can't buy.
They're not participating. I don't see how anything will happen on train.
Right.
You let Brian.
Yeah, last year. But he's moved to some other role. He's not in Xilinx anymore. He left it completely. Yeah. Yeah.
Seems like every time we try to reach out with the trainer. Even a year before.
Mm-hmm. Okay.
Let's move. Sorry. I want to move this. Okay.
Okay. The RISC-V stuff is depending on your hardware availability, it may get another, it may not, right?
Yeah.
Okay.
It's very stretchable. It's a stretch code.
Stretch code. Okay. Okay. So, but if that happen, you will own it, right? You'll create the driver. Okay. Sounds good. Cool. Okay. Sounds good. Okay. So, any other device to talk about? So, Ekan, could you pass some documents on SM310? It's not public. Okay. Okay. Sure. Okay. Okay. So I'm going to grab some coffee. Let's take a 5-minute break and start 4:25. We have wrapped with the previous topic. We can start with Eco's topic.
Okay. Pico,
Okay.
would you like to share your screen?
Oh yeah, yeah. What exactly is the topic, Eco? So what will you be talking about?
I want to talk about our entity situation and our problems within
Okay.
with using Cyborg.
Okay. Okay.
In this thing, I prepared a slide to explain them.
Mm-hmm.
Okay.
I'll just listen and okay. I'll stop the sharing.
Can you please record? Okay. Let me talk about our identity situation and facing problems. I am Ikuo Otani from Japan. And in the second slide here shows agenda. Well, first, I introduce myself and our team. And second, our activities about bug fix for some functions. And next, I shows future functions to improve usability of Cyborg and the summary and our contribution plan. Okay, then let's start. So thank you for sparing me for the time to explain our situation. In the third slide, I introduce ourselves to you. NTT is a network carrier in Japan and composed of several operating companies. And NTT East and West are regional communications business, and NTT Communications is long distance and international communications business, and Docomo is mobile communication business. And our team belongs to NTT R&D laboratory.
NTT R&D?
Yeah.
Oh, the top one.
Top of the
okay.
groups.
Okay.
And the next slide, our introduction of our team. So we are contributing to some communities about for OpenStack and DPDK. For example, Tetsuro Nakamura is a core developer in Basement and Blazor, and Yasumi Ogawa is a core mentor in DPDK and SPP. SPP is a soft patch panel which connects physical links and VMs using DPDK technology.
Okay.
And for me, I am Ikuo Otani and a developer of FPGA for NFB. And I want to be a developer in Cyborg.
Oh, well,
Very good.
Yeah.
Well,
And NTT 80 is a cooperation partner, so 2 persons can cooperate for Cyborg working.
okay. So you have 2 more colleagues.
Yeah.
Okay, cool.
2 more colleagues. Is that listed in the slide or not in this slide?
Not in this slide, but
I see.
2 or 3 persons can cooperate with us. Okay. Then the next slide. This page shows our activity about Cyborg. We showed a demo in NTT R&D forum in November in last year. So we developed some FPGA functions, and to control them, we used Cyborg. And in the picture, the left one shows initial condition in which FPGA pass through the packets to the VMs, but VMs is a bottleneck for the packets. And in the center one, we use Cyborg to change the FPGA function to switch load balancer. And we can load balance the packets to some VMs.
So are you reprogramming the FPGA bit stream while the VM is running?
Yes.
But that could be dangerous. If the VM is doing any packet transmission, it may affect the PCA transactions.
Yes, but this is a demo to control the FPGA.
Okay. All right.
And the third right picture, we add other FPGA function to by deploying the another load balancer, and we can treat more packets than the second one. Okay.
It would be simpler, just a thought, for a use case, it would be simpler if you have multiple VFs in FPGA, you assign one to a VM, right?
Yeah.
When you need to split like this, you assign a second VF to second VM without disrupting the first VM.
Yeah.
Then you go to the PF to decide which flows go to which VF. So you can change the flow steering dynamically without having to reprogram the FPGA. Yeah.
Then we cannot use multiple VLs, so I used one VL.
Sure. For demo, it's okay. In the real world, you may want to consider different solutions.
Yeah.
Just discover dynamic of just to create a static record and to end FPGA.
So the question is how to deploy or
So how do you how does initially how does Cyborg do this?
In this environment, one computer node which has two FPGA board and one controller, and we used controller node to control the computer node by OpenStack Cyborg.
So the only thing you're doing is reprogramming. You are not spawning the VM using Cyborg and Nova.
We didn't use Nova but Cyborg to reprogram it.
Right. Okay. Got it.
But there was some bugs to use the programming tool.
Okay.
So we fixed them.
Okay. This is in version 1 of the APIs, right?
Yeah. This is Rocky version.
Oh, okay. That will
Rocky version of Cyborg.
Okay.
What we can do is, we can do fixed screen programming, right?
Yeah.
So we fixed or created some codes to reprogram the FPGA.
Okay.
So you use the reprogramming
We used FPGA conf and script containing the FPGA conf.
Okay.
And cooperative operation with Cyborg and FPGA conf. Okay. So this is our introduction, and next I shows some bug fix for some functions about for new 3D model and for Cyborg client. In page 7 shows bug fix for new DB model. I saw some DB model changes have occurred,
Right.
and so we fixed some bugs to use new DB model via API version 1. So the problem is two. One is the Cyborg deployable list doesn't return. So we fixed sysinfo py to use deployable list command.
Is fixed already merged?
Sorry?
Is fixed merged?
No. I'm sorry.
I think it's based on the Rocky release.
Rocky is
And we define our DB model.
so
So this may not be applicable.
yeah, we fixed some bugs, but don't upstream them and merge. I'm sorry. And the second problem is FPGA program error. So we fixed some Python files, you can see. And this bug fix is attached in the last page, or this slide.
So what is the program error actually?
To use use new DB model by API version 1.
Okay.
I think that was the remember our showed that in class so that Charlotte and I was working over Windows. Okay. That was really
Okay. And the next page shows bug fix for Cyborg client to use Cyborg deployable list, which doesn't work. So we fixed some files and create deployable shell default to accelerator shell file.
This is good work.
Yeah.
If you had spoken to us, we would have probably pointed out that the DB model is going to change anyway. So
Yeah.
So,
I see.
Yeah, right.
So we want to talk about what should we do to these bugs next. So
we actually we moved to different code base and we put in some programming stuff for that. Now moving to version 2 of APIs, some further changes. I put in some programming changes for that. So with all of these, it's not clear that we need these specific changes because it's based on some Rocky release stuff, right? So you could look at our current code, especially pilot code, and see if that works for you. You can even deploy the pilot code and see if it can reprogram.
Okay, I'll show you in the next slide. And from next slide, we introduce future functions to improve usability, and the first one is our use case. And in slide 10, the use case 1 is shown. In here, we show the flexible FPGA function change, and in this picture, several FPGA functions are shown. One is analyze, and second is capture. And in the first situation, analyze FPGA is working, but some alarm is shown. When some alarms is shown, we should capture them. So we configure the FPGA function to capture one. So we should change or reconfigure the FPGA more flexibly, I think. So FPGA function have to be changed depending on the situation, and because FPGA capacity and number of servers might be limited for some carriers.
But the FPGA reprogramming may take some time.
Yeah.
During that time, you lose packets, right?
I see. But this analyzed FPGA is analyzing the mirrored packet, so not mainstream packet.
Well, okay. Nice. Okay.
So these two FPGA analyze and capture need to change or always change. These two is all change.
Yeah. At first, FPGA is analyze FPGA only in one FPGA, and we should all reconfigure the FPGA to capture one.
Are you saying moving some sort of API or some way to record statistics from So this statistics are traffic from the PTG file space or memory space, and then someone has to pick it up. That's
So this is one use case to explain our situation. So we do not define the APIs or something. So how to realize this situation is to be discussed.
So basically, use cases, FPGAs monitor some traffic. You encounter a certain pattern, it should be notified to Cyborg.
Yeah.
Cyborg should go back and reprogram it.
Yes.
Yeah. Okay. How do you know which bit stream to reprogram with? Who provides the information?
So I think some patterns are provided before we deploying some function. So this situation needs this bit stream, and this situation needs this bit stream. So such a situation is shown in the next slide, because in the next slide covers the recover from failure. So in the next slide, in this picture, some FPGA is become for a failure state. So we should monitor the status of the FPGA and inspect them and notify them to the operator, and finally controller have to reconfigure the FPGA. So FPGA status have to be monitored and reconfigured promptly if the failure happens. And in this situation, it may interact other monitoring or inspection components, for example, Congress or something.
Well, so if you don't mind, can you go back to the previous use case?
Yeah.
I have a suggestion. So suppose we capture all these streams and report them at collect D to some higher level, to some higher layer software. It's receiving all these things. And when it sees this particular pattern, it's going to turn around, call Cyborg API to reflash the bit stream.
So user space application for monitoring.
The Cyborg itself can collect the performance counters for FPGA and keep feeding it to collect D. It's not done yet.
Yes.
If you use collect D, you can use any collect D plugin for oscillometer, telemetry, any of things you want. So you can have some higher layer which receives all this data, it processes it, and calls Cyborg. So that way you're not hard coding this kind of application logic in Cyborg, but you're using Cyborg to drive your application logic.
So I did encounter this like the requirement. So, but the challenge is different IPs of this, right? And the statistic that some of the data some of the others different KPIs. I think
It's easier to sit closer.
what we can do is the first thing we standardize. Before we start anything, like we start we formalize what's the stuff we need to upload, right? We need to connect where we upload and how we provide a driver into the radio app. But we need to translate the stuff we connect from the hardware into the language that Cyborg. So probably how you guys can help with that. Make sure this is standard.
It's also a job for generator driver. So we want, as we mentioned in the Cyborg, you can advertise line 684 to 684. It's a requirement to collect the statics. Yeah. So we can use it. We can define some standard statics and also can define constant statics into it. So the whole process, like the Cyborg driver, I mean the agent should have a periodic job and call the driver at some get accelerator or get device statics interface, and then put it in database, and then we need a new API like maybe add device statics or something.
Right, sure, right.
The agent won't call.
I'm sorry, lost the sharing.
The driver will
Sorry.
It's a periodically task in driver.
You mean driver access the DB directly?
No. The driver report to the agent.
Yeah. But we need a periodic job to call the agent matter. Like
Yes.
Yeah.
Back to something periodic, and then this matter goes called driver interface.
Mm-hmm.
Right?
Yep.
I mean,
Oh, the driver interface for what?
yeah, because the driver will define the get accelerator statics interface, because kinds of the vendor driver maybe have some different implementation to guide the yeah. It's also mentioned in generator driver.
Yep, makes sense. Yep, I agree with it. Can poll periodically. The other thing is we have to feed it to some agent like collect D. Like my only feedback was that instead of putting this logic like look for certain pattern, reprogram inside Cyborg, should be a higher layer. So something's receiving all your packet statistics, doing your application stuff, and then calling Cyborg back, do the reprogram.
I see. What you want the Cyborg to is just provide it can carry the settings and then the high level it they could do something to convey.
But are you really going by the performance counters, or are you going by some traffic, packet traffic? Which one is it?
So the failure state or
This one, the analyze FPG.
yes, yeah, this detects some abnormal traffic. So the packet count or something.
So it's actually looking at network traffic, not
Yeah.
performance counters.
Yes.
If it's a network traffic, it's fairly simple. You can put up a VM, receives all this traffic from the FPGA. It's going to monitor it, and then when it detects the condition you want, it's going to call back into Cyborg API somehow.
So the performance count or correcting function is work in progress or future works.
Which one? The performance counter collection is future work. Yeah. If you want to just look at the packet statistics, packet flow, it's not even about Cyborg. You can just pick up your network traffic on FPGA and give it straight to some VM. The VM can do whatever it wants. It can do it even today.
I see.
How are they going to visualize?
Visualize? So he's got some trigger to detect some kind of pattern in the traffic flow. I mean, he sees a trigger, he wants to go and start capturing the packets, capture FPGA kind of thing.
No, what I'm saying is like collect the data, right? Like the parameters to put it without.
No, he's saying it's not the performance counters. It's actual traffic flow. It's not, you're not looking at the counters in FPGA every 5 minutes. It's real-time traffic coming in, and somebody's monitoring it and switching to the capture mode.
So we are developing this analyzing FPGA, and in which we can analyze packets by sorting with 5 tuple or 17 tuples or something.
Okay.
So we can use them to know what the flow is coming with many packets.
So very basic question, okay? Maybe I'm missing something here. Why can't the same bit stream do both analysis and capturing? You have analysis mode, you see something, you switch mode, the capture mode will be like real time.
We want to both analyze and capture in the same time, but we found that analyze and capture FPGA cannot contained in one FPGA because of the capacity.
I see. This is ARIA 10.
Yeah.
Next one is static still is going to be bigger.
Yes.
It's going to be much bigger, in fact. So it's already, I can put you in touch with the right people. So you may not even have this problem there. Maybe the whole thing will fit in one FPGA then.
I see.
Okay. The old shell or
Sorry.
How are you using it?
So another team is developing now for these FPGAs. We are informed of the status of the developing, and we heard that they cannot use the analyze and capture FPGA in the same time. But they use ARIA 10,
Okay.
so they can't use the same time.
Okay.
So this is one use case.
Okay.
To explain what we should consider about the cycle to make them more useful.
Okay. To me, this seems like some higher level logic. So if you need to switch bit streams like this, you can put up.
Okay.
Yeah, go ahead.
I understand your opinion, and this is introduction and the practical problems we show in the next slide.
Okay, sure. Okay, yeah.
So in the slide 12, I introduce some suggestions and problems. As a telco carrier, we should manage FPGA resources for a long time and want to control FPGA resources more carefully and more greater kindly. And there seems to be several problems in the two steps for resource control. It's shown in the left picture. There's two steps including FPGA status check and control. And we found several problems shown in the right. And one is we cannot identify content of green region. Green means FPGA region we can reconfigure.
That's the PR region.
Yeah,
It's a PR region. We have a, we also call it a slot in OPA terms, but rest of Ultra also used to call it PR region. Comment. So there is actually, if you look at sys class FPGA, sorry, if you go inside that sys class FPGA tree in Linux,
Linux and using Intel PAC card.
Intel PAC card, there's actually a node called AFUID that gives that will give you the content of the green region.
We can know FUID, but the problem is we explain the next slide.
Okay.
Sorry. And one problem B is we cannot detect unexpected content change in green region. For example, some software error or someone other than the Cyborg changed the FPGA.
Okay. But however you change it, it should show up in the bitstream ID register to show to you. So if somebody other than Cyborg can reprogram the whole thing, it will still update the bitstream ID register.
So I mean that not Cyborg user can change the content, not using that Cyborg,
right?
Or some software. Software means the radiation from the space can change the FPGA content by a single error SEU.
Okay. Oh, okay.
This is very, very good problem. So we cannot do, I think we cannot, it is very dependent on the FPGA vendor to solve it.
Right, that's true.
Yeah, so if we use many FPGAs, the ability of the SEU is more and more. So I think we should know the content is not changed from the original.
Okay, that's a much more difficult question.
Yeah.
So, we're talking of some single bit error, parity error kind of thing. Okay. Wow. Okay.
Future works.
Okay. It's not even a Cyborg level thing. Well, the device vendor needs to provide that.
But we can supply some API for some detecting function or some.
For the DDR, I think we've got ECC memory, error correcting code.
Yeah.
So I think we have that. So single bit errors will be caught and corrected. But for the FPGA chip itself, I'm not sure. Okay, we're going to find it. Okay.
If another application is that you could only
No, he's saying what are some radiation from outer space came and put the FPGA and we get a single bit error. So the electronics inside the FPGA is flipped.
So the circuit can be changed.
Yeah. Right.
Unexpectedly.
Okay, I'll take that as an action item and get back to you.
And the third, problem C, we cannot detect FPGA is ready or not. We can know that by vendor tool, but we cannot know that by Cyborg itself. And
What do you mean by FPGA is ready?
if the FPGA is open, we cannot reconfigure the FPGA.
Uh-huh.
So I think there should be some means to forcefully open the FPGA and exclude some program to reprogram ourselves.
So are you saying when the VM is currently using it, should be able to bump out the VM forcefully and reprogram and oh boy, okay. Oh boy.
We were in trouble to we were in trouble with this program to program in the to make the demo I showed.
But that will be considered a backdoor by many operators. Somebody could abuse that and kick out VMs. We'll have problems there.
Yeah, I see.
Right? So what is your use case though? Why do you need the ability?
So I think the problem is we cannot know the FPGA status. So FPGA is ready to reprogram or not.
If it's currently being used by a VM, we should not reprogram it. If it's not being used by VM, you can reprogram. That's all Cyborg's logic say.
And we think about not VM, but some other components or drivers open the FPGA.
Okay.
So very physical layer or some.
Yeah, even at that level, at least for Intel products, your kernel driver will know if it's being used or not. If it's currently being used on the
So are you asking? I'm trying to comprehend. So I understand you're trying to evict VM from using FPGA. So the three ways of looking at it. One is basically you evict completely, and who cares what happens to VM.
Right. Right.
So the second way is you have orderly shut down the VM.
Mm-hmm.
And then basically you shut down the VM, you put device, and I deliberately call it device because it's a critical cross-border into maintenance state, for lack of a better name, and then you are allowed to do certain operations, otherwise are not allowed.
Right. Okay.
And the third thing is variation of the migration of the VM. And you can migrate VM from the device to a different device of the same node.
Yeah.
Or migrate VM from one node to another. And I have no idea what level of migration was discussed before for Cyborg, and what is feasible, what's not.
So typically migration will not work with PCI pass-through.
Yeah, I know. That's why I'm trying to understand what is feasible, because you'll have the same problem for FPGA, smart NICs, and then you go down the line.
Yep.
I don't know, maybe at some point in time somebody will have things which is possible to do.
Mm-hmm. Right. Yeah, that's a long range anyway.
I know, but then as you are addressing this problem, you for sure, so it tells me that we need to come up with the state of the maintenance.
I'm just trying to understand why he needs to do all this stuff. Why does he need to kick out a VM while it's running, all of that? So could you explain what is your need for this mechanism? So basically, why do you want to reprogram FPGA while the VM is running?
I am saying that I mean that the Cyborg should reprogram as they like, when they want to do it. So some other, not VMs, but some other drivers or programs using use an open FPGA, the Cyborg cannot use open or reprogram the FPGA.
Yes.
So the operator, how operator knows that we can reprogram by Cyborg or not?
Okay. So I think the answer to that is if the operator can check if the FPGA is in use, then he also knows it cannot be reprogrammed. If it's not in use, it can be reprogrammed. That level of API will be adding in train anyway. We'll be adding API to see whether the FPGA is in use or not.
Who checks the FPGA is the not Cyborg, right?
Sorry, say it again, please.
So someone but Cyborg should check the FPGA status.
No, Cyborg will know the FPGA status whether it's in use or not. So you can query Cyborg API to know if a given FPGA is in use. If it is in use, you also know you cannot reprogram it right now. If it's not in use, you can reprogram it.
Because the assumption that you program the FPGA while yes, has to be like there's no other users using. Some other users using. But I don't understand your use case, but if you're deploying the VM, like with a couple VMs that you know is by you, and those VMs are using the same FPGA and you release like all those VMs and you spawn the new ones, new capabilities, that should serve the same purpose. So that way you can totally utilize the lifecycle management cycle for the VM and FPGA. And then you can also evaluate so that you can also safely check if this FPGA is totally free.
I see.
Because if you allow the VM user to, or a VM itself to decide whether to reprogram it, you should let the management decide whether to do that. Or you can decide, or from disaster recovery point of view, before you release these VM and FPGA, you can spawn new ones first. And you can start already flavoring two FPGAs from here, but right? You spawn two other ones before you copy these. And then you start clicking on the other side, check everything good, and then you repeat. So that you won't have any corruption. So in my opinion, especially to acquire some of the this kind of capabilities here from Reddit, that's a lot of investment. What can be done, right? Especially by these hardware changes. I don't think it's going to be because of how just some. Just that
I agree with that, but I still believe that there is a need for having a maintenance state, so no one will not schedule anything on nodes that doesn't have that device.
That's actually that one you don't have to do that. You could do that inside.
Yeah, that's what I meant. In Cyborg, we create a maintenance, we create a state such that no one knows that the device is not available for it.
Right. Sure.
And then you can, decide how to put the device into that state. I'm not going to touch how to defeat everything. But where device is not used, you can put on the state, so you don't have a race function.
Right.
You only the status that
Mm-hmm.
to identify that it is.
Not today. The proposed API allows devices API to can query this with news or not. Today we don't have it.
And from next slide, the solution we take is shown. And from in the slide 13, problem A solution plan is shown. Problem A is we cannot identify content of green region. The problem is split in three parts. The first is image UID is written before program is done. And the second,
I'm sorry, when you say image UID, refer to glance UID that is written before programming is done.
Image UID is written to the some DB of the Cyborg.
Okay. Oh, I see.
It
Okay.
is done by before the program is done. So
Yes.
it makes some meta state because FPGA programming is failure, but the UID is written to the DB.
It's a good point. We should do the right order.
Yeah,
Okay,
yeah. So please change the orders. And the second is image UID isn't directly related to AFU information because UID is just a glance UID. So
Yes, this part of the proposals we have. This is said we should add the FYD, either function ID or function name, or maybe both, and add both metadata. Sure. Yeah.
yeah.
Is this similar to the?
Yeah, yeah.
Yes, exactly. Yes. Yeah.
And the third one is AFU information may not be enough, I think, because it is device vendor dependent, and AFUID may not be unique for specific bit stream.
I think what you're saying is for one bit stream is one FYD, but two bit streams may give you the same FYD. Is what you're saying? Because one bit stream by definition has only one FYD.
Yeah, but so if we rewrite the variable or something in the file and make them to the bit string, the FAID is changed.
Yes. Yeah. It'll change. Yeah.
Okay.
Well, it could change depending on how you do it. In the RTL, you may want you could ensure to get the same FYD depending on how you do synthesis. When you say it cannot be unique for specific bit stream, add bit stream identifier sum into attribute for unique index.
So yeah. So our session plan we can add some MD5 sum or something to for the unique index.
Sorry, unique index of the function ID. See, the problem is this, right? You could write some OpenCL application and synthesize a bit stream for, let's say, ARIA10. You synthesize another bit stream for static step. The two bit streams the same function ID. So we do want the user may say, just give me a gzip somewhere. I don't care if it's ARIA10 or static step. So you may want that.
Yeah. Okay, so the function ID is the essential, but this checksum is not the essential.
Exactly. Yes. Yeah.
Because it depends on the bit stream type.
This will depend on the bit stream type, correct? But more generally, several bit streams may correspond to the same function ID. Because, like I said, let's say you write an OpenCL program for, let's say, doing gzip.
If
you target it at ARIA10, you'll get one bit stream.
ARIA10, yeah.
If you target it static stream, another bit stream. For the same function, it's all gzip.
So, but it should be the same for the operator.
Yes, the operator may want to treat it the same thing. Yeah.
I see. Okay. So in our solution plan, the first one is approved or
Yeah, I think
missed order change.
yeah.
Okay. And the second, FU ID, this is the function ID, so in the mapping discussion. So
Yep.
okay, it's
Yep.
okay. And the third one is not needed because it is not for it is not essential for the operator.
Right.
Okay, I see.
Okay.
And then the problem C solution plan in the next slide. The problem C is we cannot detect FPGA is ready or not. So Cyborg itself cannot know whether FPGA is ready to be programmed or not. So we used OPA2 to know the status. But you said, but we you can know the FPGA status by Cyborg command.
In the future,
In the future, yes.
we'll add some APIs for device in use or not, kind of thing.
I see. So this is just the workaround plan to because we used Rocky.
Okay. 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 Sure.
Okay, I see. So the command is a command in train release or
It's planned. It's one of the things we proposed. Yeah.
okay. Okay, that's all. And our trial status and what the next is in the next trial. We try to fix Cyborg code to solve these problems, and we and found some bugs around with about trial which are fixed. We fixed, and we so in the next step, what should we do? Shall we make fix or something? But
I think for many other solutions we're recommending, I think we're planning to do it anyway.
yes.
Yeah.
So okay. So yeah, I see. So we need not to prepare some specs, but to cooperate to make some specs or codes in the next piece.
Yep. That'll be useful, definitely.
Okay. Okay, then proceed to the summary. In the slide 17, summary is shown. We fixed some bugs to install and operate in the Rocky release. And should we propose them to the community and upstream them?
At this point, the code has moved on a lot, so the old patches may not be applicable anymore. But I would suggest that you can try with API v2, just like you said.
Yes.
And if it works, well and good. If it doesn't work, please file a bug report and we'll.
Okay, so we don't need to upload version 1 bug fix, but we should fix it for the version 2 API.
Yes.
And the version 2 API is already made.
It's sitting in a side branch of Cyborg right now. Once the community reviews it, it will get merged.
Okay.
And you're welcome to participate in the review.
I
You
see.
could please review the code. Yeah.
So, okay.
Yeah. That's a side branch what I'll be demonstrating tomorrow.
Oh,
It's the V2 API.
I see.
Yeah.
Okay, we will to version 2 API.
Sure.
Yeah.
Yeah, sounds good. Thank you. Appreciate it.
Okay. So, okay, for the train release, we should contribute and develop some code. Thank you.
Sure. Yeah. So you can actually deploy the version 2 API in this pilot code, check it out yourself, find bugs, please let us know.
Yes.
You can take it from there. Sounds good. Cool.
Okay. Some bug fix we have shown in the next slide, and this is
Okay.
for version 1 API.
Okay, so please do send this to us.
Yes.
We can check, even version 2, maybe the same problem is still there, maybe. Let us go and check it out. So, yeah. Cool. Good. Thanks a lot,
The
Eco.
only one from the company that will be able to code.
So we are a team who use Cyborg. So I and some person from NTT is tackling these problems to using Cyborg to control FPGA.
How many resources?
So 2 persons beside me can make the code. Total 3. But for the time being, I am the main person to the committee.
Sure.
And in the box, some persons to make calls.
Sure. Sounds good. Cool. Very good. Thanks a lot, Eco. Appreciate it.
Yeah. I'm sorry for not contributing some calls because we are shy.
That's okay. Don't be shy anymore.
Yeah,
Please.
yeah.
Okay. Yeah.
Yep.